What is up? Daniel here with the Virtual Robotics Studio, and we are back this time for a special edition of Virtual Robotics Studio. We're going to be, instead of in our studio here filming, we're going to be live at a workshop where we're going to have a bunch of teams working on getting their robots up and running and coded. So we're going to go through kind of the whole programming process with those teams. It's going to look a little different, it's going to run a little different, but hopefully you still find the information useful. All right, we're going to get started with that, but before we do, as always, another special thanks to Argosy. First, Aramco, West Coast Products, and Cross the Road Electronics. This microphone on, this microphone off, this microphone off. You will need a USB-C cable. There were short ones in the Spark Mac boxes, and then there was a long one if you had it from before in the PDH box. Do I have one? Do I have one that reaches that far? I'm leaning towards no. Us get started. So we're going to start working on the rest of our program setup. Remember, we already did the image for the RoboRio on the SD card yesterday. Most of you had somebody go over and do that. So our image is set on the RoboRio, but we still have to set our team number. So that's the first thing we're going to do. And I guess there's a couple different ways to do it. I forgot I had this microphone too. In the RoboRio imaging tool, there is the ability to do it from there. I guess there's some bugs right now where it might tell you it failed when it didn't fail. So instead, if you guys hit your start menu. This should have gotten installed for you when we installed WPI Live, but we're looking for WPI Live team. Oh, just look for team number setter, and yours should be 2026. And you're going to plug the USB cable in your computer, the A side in your computer. The square side then is going to go into the square port on the RoboRio. And then you're going to need to turn your robot on. If you don't turn your robot on, we will not be able to see the RoboRio to do anything to it. And it takes the RoboRio, I don't know, like somewhere between 30 seconds and a minute to boot up. So anybody got any good stories? Was everybody able to find this, the team number setter? Hear text clearly with natural voices. What does that have to do with magnifier? Ah, that makes sense. All right, go ahead and put your team number in. I believe my robot is set up as 9999. You should type in your actual team number because we set up your RoboRio and radio for that. And then does anybody have something showing up on the bottom? Any text down here? Yeah? Does anybody not have stuff showing up? It's literally just me. Hey, I'm part of the club now. Cool. So you have your team over here, and then you can just click set to team whatever. It's going to deploy for a second, and then you can do refresh status. I don't know. It's probably fine. We're going to test it in a different way. Okay, once that is done, I think you can close this. We'll open it again if it didn't actually work. And now, go ahead and run your FRC driver station. We can say yes. And the driver station always takes just long enough that you start to wonder if you actually click on it or not before it pops up for you. Okay, let's do this. We could do a test. Well, we are plugged in with USB. If you go down to the second tab, you should see the USB light is lit up in green. Also, just because we're plugged in with USB, at some point you should get a green communications light. Let us know if you don't see that. No green? So there's a chance that there's an issue, and there's a chance that it's just, you know, the RoboRio being a RoboRio. Our next test, which you can also try, is I want you to unplug your USB cable. And we're going to see if we can connect through the radio to our robot. So pop up your wireless networks. By the way, as I'm popping this up, this is a good chance for me to say thank you to the Ann Arbor District Library. That's AADL, the wireless network you're seeing here. They're hosting this workshop, so definitely thanks to them. And then a lot of the area teams, a lot of the Washtenaw area teams have been supporting us, getting the field put together for us to use later, and just being here helping the teams get robots put together. So that's awesome. Now, you should find your team number on the list.
Make sure that you set the team number in the drive section.
Yep. Yep, so pick your team number here. I'm guessing I'm 999 demo. I think you have the option when you program the radio, you can add an extra thing on the end when it shows up. So I don't know, if it doesn't work, that's fine. You want to make sure you connect automatically. And as we're doing this programming thing, when you're like, it doesn't work, the #1 problem is going to be you're not connected to the robot's wireless network. You connected back to the library's network. Check that first. This is going to take some time to connect. When it connects, it's going to say like connected, no internet or something like that. That's what we want to see. That's bad if you're trying to like connect to the Wi-Fi at your house, but it's good here because the robot is not connected to the internet. So no internet open, that's fine. You might have no internet. No, I don't think we set up keys for any of you. So that's what we should see here. If you are using your radio at home, there will be a key in. So it'll say, I think, no internet secured instead. Either way, we're happy. Now, in the driver station, if you go down to the setup tab, you need to put in your team number if you have not already done so. All right, and then I know everybody here is a second-year team, but just really quickly, maybe there's some stuff you didn't know. The first tab on the driver station is our operations tab. Here's where we can choose to do teleoperated autonomous, practice, or test. Test, there's like a place in the code where you can put test-specific code if you want to test one thing and not have your whole robot code running. Practice will do the same sequence on the field. So it'll do autonomous, then teleop, then endgame. It'll play sounds for you, all of that stuff. And then teleoperated and autonomous should be, self-explanatory. Team numbers here. We should see connection lights, so that I don't is not a great sign. I'll check on that in a second. If you go to the diagnostics tab, you should see Wi-Fi, you should see robot radio, and you should see, that's pretty much all you should see. Your firewall light, if it's not green, if you got a red firewall light and it's like saying DOM pub pra or whatever, that means your firewalls are turned on. Firewalls occasionally, but I would say somewhat rarely, cause problems. So if you're having connection issues and things aren't working right, you might want to go in and turn off your firewalls, which I think if you go to security, or I think even if you just type in firewall, you can do it from either Windows Defender Firewall with advanced security or maybe even just the regular Defender Firewall. I probably wouldn't bother with it right now if it's working, but when you go to an event, they're going to really want you to turn the firewall off when you connect to the field. If it's working, the reason why I'd leave the firewall on is because if this is my programming laptop, there's a really good chance I'm going to be searching for stuff on the internet and looking for things, and the firewall does exist for a reason, so I don't know. Maybe it's nice to have on, but you will want to turn it off when you go to the event where you're only going to be connecting to the field. All right. You have the ability to reboot Rio and restart robot code here. So this is something to keep in mind. If during a match your robot, the controls aren't working, it's possible your code crashed and you can do one of these restart buttons to get it to come back during the match. That's pretty much the only use I have for this. If I'm doing it at home, I usually just turn the robot off and turn it back on again and wait the extra minute. All right, in the setup, in addition to your team number, you can change the dashboard type. I think our code, the default code that we're using, is going to pop up, is going to use the smart dashboard for autonomous selection. So we're going to leave that alone. It does say it's deprecated and will not work with the 2027 control system. That's fine. This is not 2027. Ignore the note. Interestingly enough, the timing I think is wrong. You guys can correct me, but I believe autonomous is not 15 seconds anymore. It's 20. So if you want to match what's going to happen on the field when you're doing your testing, you would have to change this to 20. And teleop plus endgame is, I think, right? Teleop needs to be longer too. I I can't remember if it's 110 or 115. But teleop got extended, autonomous got extended this year. Keep that in mind if you've done this before. All right. And the USB section, this is where we're going to plug in our gamepads. And when you plug in a gamepad, you have the ability to drag it to different ports. So if it's in the wrong port, you can just grab it and drag it where you want it to be. We're going to set it up so that the driver control to move the robot around is going to be port 0. And then we'll do a second gamepad, which is going to control the fuel mechanism, which would be port 1, I think is where it'll get set up to. If you don't have a gamepad, I have a bin over there with many a gamepad that you can come in and grab one to borrow. For the purposes of this code, we're going to be using an Xbox or Xbox compatible controller. You can do it with other ones, but you'll have to make some additional changes. And then there's power and CAN, which I pretty much never look at the screen, but it could help you troubleshoot if you have issues. All right, so is anybody else not connected to their robot? We want to see connected here on everybody's thing. If you still have no robot or communication and no green lights, we got to figure that out. Anybody else not connected? You should check the rules. I don't know 100% what the teleop time is. I know it's longer than 105 seconds, but I don't remember if it's, I think 115 sounds right to me, and then 30 seconds of maintain, so 145 total, but so to do practice mode to match what happens on the field, they changed the game length this year. So they didn't update it here. So if you want to make sure you have the same amount of time, like if you want practice mode to get the feel for a match to your drivers, then you want the time. But if you just tell the out, drive around as long as the battery lasts, you can practice it. Well, there's that. But you should practice it all this year. Okay, so my problem, and I think pretty much everybody else's problem in the building who was not able to connect just needed to reboot either the Robo Rio. I rebooted my whole robot because that seemed easier, but that worked. We're connected. Okay, so now we know that we are, I mean, everything is good. We're connected to stuff. We're happy. Let's take a look at the Spark Max devices next. So we're going to look at these really quickly. I think most people had them set up, but we're going to jump into that just to review. So you want to run Rev Hardware Client 2. And sometimes it feels like the Rev Hardware Client 2 decides to like reinstall itself when I run. I don't know. I think maybe I'm running the thing and it installs itself and then runs. Anyway. The way to do this is generally speaking, you want to turn your robot off. Plug into one of your Rev devices. In our case, we have 2 Spark Maxes that we want to work on. If this shows up as there's a device, but like it doesn't show what it is or anything like that, that means you have to do the like firmware update recovery mode thing. To do that, you unplug it so it powers off. there's a little button on the Spark Max that you press down with a tiny Allen wrench or paper clip or something. Then you plug it back in to power it up, and then you'll have the option to update the firmware. I think we did that for everybody's here, so you should be good to go. If you click on the device that you plugged into, it will show up here, and mine is not set, so I'm going to go ahead and try to make mine match yours. So I think all of yours got set to CAN IDs 21 and 22. If I remember correctly, that's what the tape on them says. You can leave that. It doesn't matter. You can change it if you want. Here's the thing. We have two different CAN networks, right? We have our Canivore with the CAN FD and all of our Swerve drivetrain stuff, and then we have the CAN network from the Robo Rio powering these two other speed controllers. So this network and the other network can have the same IDs. Essentially, the different companies can share IDs. So I can put something on CAN ID 1 for a Spark Max, and I can put one of my Kraken motors, or a Talon FX speed controller for the Kraken motor, on CAN ID 1, and there would be no problems. I think that's a little confusing, so I like to pick different numbers. And that's sort of why we're at 21 and 22, because it's way far away from everything else. I'm not sure what, I don't remember offhand what ID the Kitbot uses as the default ID. Just know that if you are using, if you're looking at some of the Kitbot code and stuff, it's going to be, actually, I know now because I looked. The intake motor is 5, and the feeder motor is ID 6. So if you want to just match that, you can change yours to 5 and 6 as we go through right now. If you don't care, and when we do the code, you type in 21 and 22, and you don't need to worry about it. Just know that if somebody is helping you and they're looking at the Kitbot instruction manual or whatever, the code that came with it, just know that your numbers should be different there. It exists in one place in the code where you type in a different number, and nowhere else, nothing else changes. So you can go either direction. I think having 5 and 6, and then when we do the drivetrain, having a 5 and 6 is more confusing to me. So I'm going to stick with that 21 and 22. So right now I'm plugged into, by the way, the Spark Max on the front by the Robo Rio is going to be controlling the launcher. The Spark Max that was on the back, I guess closer to the power switch, that one is going to be the one that controls the feeder motor. So if you want those numbers to match up, then that's the way to go. On your robots, we kind of plugged them in. We wired them randomly. So some of you might have 21 right now as the default for the feeder, and some of you might have 21 right now as the default for the launcher. So I'm going to follow first order, and I'm going to say the launcher motor should be my lower number. So I'm plugged into my launcher. That, again, is the one that is next to the Robo Rio, and I'm going to make that one 21. So if you want to be the same numbers as me, do that. But again, it's just one number that we're going to type in later. And then I'm sort of split on whether you need to do this or not. But the default motor type here is brushless. I always change it to brushed. I think you change it in the program and it updates and it's fine and you don't need to do it here. But I am a paranoid, so I do it anyway. And then once you've got those two changes, you've got to click the persist changes button down here on the bottom. And make sure that takes. So you should now see your Spark Max CAN ID 21. Okay, then we're going to repeat this process. You can unplug from the device that it's in, plug it into your other one. We only got 2 to deal with here. And it's only Velcroed in, so you can lift it up if you need to. By the way, if you don't get the spinning loading device thing, or you get the spinning loading device thing and it never changes, I've had that happen to me several times. It seemed to fix itself by unplugging and plugging the USB back in on my computer or switching USB ports on my computer. So you may or may not have that problem. And then this one is going to be 22 for me. And I am going to go back to configuration and change it to brushed and persist them changes. All right, anybody stuck with that or have that not working? And the lights turned on? Oh, one thing that might help, sometimes the robot being off helps. Plug it back in, and then if that doesn't work, try the other USB port.
Yep, fine, too.
Is this what it did before when it wasn't working? Just spun forever? Try the other USB port.
Well, the first time it was just not showing anything.
I forget the spark max.
Yep.
The thing is, here it should show, it should still show something, even if it needs to be in hardware recovery. It is.
Or doesn't that little like pin thing? I was told it
Yeah.
would show up.
We'll try that next. That's the next thing to try. So we'll unplug it from the computer. Hold down the reset button, plug it back in.
Oh, is that one?
Plug it in the other USB port. Plug it in the other USB port. Is there another option?
No.
See, this is the one I was talking about, where sometimes just nothing happens. Okay. One thing we can try. We can try the other one. Yeah. I've had this happen as well, where the only option really is to. We'll try this one, not recovery mode first. I think there might be some USB situation happening. I think a second computer might fix it.
That has a USB-C port. I have a hub. Try it.
We can try that. That should be a different USB control, host controller, right? Like on the board, so that might make a difference.
Maybe, yeah.
Let's see. Thank you.
Did you already put the Spark Max in safe mode?
We tried that. I have a feeling another computer might solve the problem.
Don't get your hopes up.
Well, it's better than the not seeing anything. Now at least it sort of thinks it sees something.
Nope, it's sad.
Let's try
Oh, it
now.
might have the wrong. Yeah, I think it's it. Like, I don't know.
Nah. Right?
That's worth a try.
All right. If we grab another computer and give another computer a try, worst comes to worst, we can grab a known working computer and see if that goes. I had this problem before too with this software, so I don't know if I would blame you this time. Last time though. Yeah, that's true. That's true. It should be today. I mean, we can reboot it though. It is possible that does something.
Different USB cable?
A different USB cable could do it. Seems. I mean, feels like everything is a guess at this point. But it is definitely there's some USB driver something issue that's, I think, at play here. Rebooting the computer, yeah, it definitely has a possibility as well. I've read stories of rebooting the computer didn't work for this particular problem, but I would still try it at some point.
I've also experienced some cables with.
We'll swap it up.
broken,
Yep. Yeah.
lines.
That could be. Well, we tried a different Spark Max, so now we're trying a different computer and a different cable. And then if that doesn't do it, Yeah, we had the light before. If you hold the button down to do recovery mode, there'll be no light. If you don't do it, it'll just power up. And this powers up enough to do the control logic, but not actually send power to motors.
Okay. They swapped their Spark Maxes out yesterday.
Hold the button down. Oh, yeah, then just click on this. Oh, close this. Close the program. Connect to the internet. Connect to AADL internet, and then redo the process, and it'll work. It only works if you're online.
I have a pen for you as well. I'm excited for the next part.
Yes. Now that I'm not going out live on the stream to the video, yeah, this software is buggy as hell.
Were you able to get it going?
And I understand our major sponsor of this event would be happy for me to say that, but
If you just look up like the Rev hardware client 2, you should just be able to
nah.
You would
They don't.
administer
So now the problem is they're all the same computers, so maybe these computers just can't do it. Would you mind if you brought your computer over and saw your computer? Because we know yours can't.
Did you already swap the USB cable?
Yes. We tried 2 Spark Maxes, 2 USB cables, and 2 computers.
Okay.
So now third computer, clearly.
Third computer. Third time's the charm.
What else could it be?
The good news is you won't have to open up the client again once you get this going.
Yep.
So then that pop-up is recovery device. Swap it over because it's a framework. Yep.
That's cool.
Corey's very proud of his framework.
I do that all the time. It's great.
Let's see.
Yeah, these are
Is it 2 laptops that are set?
Well, they're the same laptop. So if it's a conflict with the USB hardware in the laptop, it's possible it's persistent across the model. On the other hand,
yes, but that's on a different CAN line. So
ain't no way 2 Spark Maxes don't work, right?
Can I see something?
you can give them different. They can have the same ID, but it's like a different company, and it doesn't work. Maybe you choose Spark Maxes that
I mean,
receive that.
what it did kind of load last time, the robot was still on.
It should definitely work with the robot off, and it should work better
I
with the
wonder if
robot
it's
off.
the wrong.
It is possible. Connect to on that computer. Connect to the wireless instead of the robot. Connect to ADL and plug in.
The brush list
He is. He is.
Oh, you are connected to the internet.
the brush motor.
I'm very quickly running out of ideas.
Just set the ID.
It can't be 2 though, right? It can't be 2, but it's 2.
Are these are brand new, completely out of box. Don't you have to load them up to Red Hardware Client 1 first?
No.
We already had one part that was.
We did the recovery mode update.
Was it able to be updated on these two?
Yes.
But you can't see outside of recovery.
We can't see it in recovery mode either now.
Okay, Corey's gonna try something.
I will plug it in.
Thank you.
Your laptop looks up. Oh yeah.
I'm questioning if they're both pushing.
Oh wait, you see there's an angry device. Okay. Okay.
You got it?
I don't think I believe, but that is what I think the problem is. There's a problem there. I just don't know if that fixes it.
Just unplug and replug. If it shows that, you can tell.
All right, I think what we're gonna do, because we can actually plug these motors into anything, let's keep going on the stuff that we will be able to control, and then people can keep trying to troubleshoot it, but we'll like focus on getting the next stuff going. All right, we still don't know necessarily what's happening back there. We're gonna keep troubleshooting, but we don't have the tops of the robots on anyway, so we don't really need these controllers to work until later. So that's it. We're done with this. You can close it. We never have to open it again, unless something goes wrong. Turn your robot back on, by the way. You can undo the USB cable. We want robot powered back on. And as soon as you can, connect back up to your wireless network. Because it's easier and we can, we're going to basically program the robots wirelessly. So we don't have to plug in and unplug cables. Now, when you go to an event, you're not allowed to do that. At an event, in order to do the same thing, the new radio on the top, there's a port that says DS, stands for driver station. You can take an Ethernet cable from your computer to plug into that port, and that will give you all the same connectivity wired that we're going to be doing today wirelessly. So make sure you have a spare Ethernet cable when you go to your event, and if your laptop doesn't have an Ethernet port, you want to pick up one of those USB to Ethernet adapters. Those usually work fine. I still don't know why I never use the refresh button. I always just close it and open it back up. What does that say about me? OK, you should have green on your driver station. We want the driver station open. We want to see the green communications light on the driver station. And then you're going to run Phoenix Tuner X. All right, everybody got this? Curious that the table having problems is the laptop that I set up. There's something like, so Phoenix Tuner X, it's a Windows app. You get it from the Microsoft Store. And it sort of like updates when it feels like it, so maybe that's the problem. Our computers usually sit in a box for months, and then we take them out for a workshop. So all the Windows updates have to happen at once. All right, we'll slowly continue forward, and then they'll be able to keep them caught up. So hit your 3 lines, your menu on the top left. Now we have some options here. Bottom left of that menu that popped up, we can connect to our system with the Canivore USB. We can connect to our system via RoboRio USB. So when we had that A to B cable plugged in, you would choose RoboRio USB if you wanted to connect that way. Driver station is how we're connected though now, right? So we're using our driver station wirelessly over the stuff. So choose driver station. And things should happen, and eventually you should at least get a green light for successfully connected to. That was, I was like 90% sure. All right, we're going to run the temporary diagnostics server right here. This is going to set up, first of all, we have no code on the RoboRio, but we got to kind of use it to do some stuff, to see our CTR devices, to set them up. We can actually run them. We can make them move and stuff in this, at this point. And this basically creates an environment where we can do all of that without having the code on the RoboRio. Or even if you do have code on the RoboRio, it sets it up so that we can do things the specific way we want to do things in this software. And this message is going to be like, success. And it's telling you you're now on that temporary diagnostic server. So if you close this software, go to your driver station and hit teleop enabled and try to drive your robot, not going to work. You got to reboot the robot to get back to robot code. Or reboot the RoboRio at least. All right, we're going to say OK. If you have to reselect driver station, do it. I don't know if I click something. Yeah. We're about to do that, I think. Click on Carnivores. Do you see it on my Carnivore is a sad yellow color? It needs to be updated. Couple things, though, as we go through. There's this button right here, which says Blink Device. Click that. And your Carnivore should go crazy. The LEDs on it should blink super fast. Now, in a little bit of foreshadowing, when we have 8 motors that are all called Kraken, guess how we're going to figure out which one's which? All right. We can update this in a few ways, but if you select the Carnivore, it's going to give us this arrow here to update selected devices. Go ahead and do that. And then make sure you're on Phoenix 6. Make sure it's 2026. Click Update to Latest. You can probably go back and install versions for previous years if you need to. But for the 2026 season, you got to be on 2026 firmware. And say OK. Now look, it's this much happier green color. Wait, gray?
Oh, I didn't have driver station selected.
Yeah, there you go. Update. Yeah, you went from deathly gray to sad yellow. It's we're getting better. All right. Does everybody have happy green Carnivores? Excellent. Now, I believe we click on devices. And here's the thing with the devices. Your devices are all brand new. Mine happen to have been used before. So where you see BR Drive, that's probably because I gave it a name before. Yours should just maybe say nothing or Kraken X60 or something, or Talon FX. We're going to change all of that. We're going to rename them all. And the chances that I put the back right drive module on the back right of this robot is what, like 1 in 4? Oh, but it's like a combination thing, so it's more complicated. All right, we won't do that right now. We're gonna move on. Okay, let's do our easy things first. And the easiest thing is the pigeon. You can make the pigeon blink too, but there's only one. So if you click on it, we can get to this screen. And I'm not going to go fully into detail on this. If you have any questions about the stuff that are in here, grab one of our CTR people. You can get whatever questions answered you want. But generally speaking, we can change our ID here. We can change the name of the device here. We can make it blink here as well. But we can also choose to update the firmware from this screen. And then the other thing, too, is you can choose a variety of signals. So this thing has, I believe, 3 gyros. We have one, apparently, X, Y, and Z. So that'll be if the robot's rotating or turning, that's the one we care about. There'll be if the robot is tipping up, like going over the bump. And there will be one if the robot is rolling over onto its side, which is bad. But you could turn those on and watch graphs of what's happening. So you could turn that on, move your robot around, and see what it's reading from that gyro sensor or the acceleration sensors or whatever's on here. We don't really need to do that right now. Let's see. We have 8 motors for our drive. And then we have the pigeon. So we're going to have 9 things that we have to give an ID to. I want to start at 1. So a default device that is just connected for the first time is going to show up as ID 0. And so I kind of like having all of my named devices be at least 1 or higher, so new devices won't conflict with the device that we just added. So if we think about it, if we do drive motors and CAN coders and steering motors, that's going to be 1 through 9 all used up. 1 through 8 all used up. I'm bad at this, starting at 0 or starting at 1 thing. All right, so 9 would be the next available spot. So you could make your pigeon ID 9. You could say, hey, I might add 1 more cross-the-road motor to do a hanger or something, so let's make it 10. Or you might say, look, all of our drive stuff is going to be 0 through 10. All of our climber stuff is going to be 10 through 20. All of our sensors is going to be 20 through or 30, whatever. You know, I mean, you could divide it by systems that way as well. It's really just whatever makes the most sense for you. I'm going to go ahead and make mine. I'm going to say like 1 through 10 is the drive stuff, and I'm going to consider the pigeon as part of the drive. And so I'll just put it all the way at 10. So it's kind of out of the way there. You can click Set. You can change the name of this device if you want. But we only have 1 pigeon, so I don't think there's any reason to change that. And then just so you can see how it works from this screen, if you click Update Firmware here, it will update the firmware. I think. I'm not really sure why the thing popped up. Oh, wait. Go to 2026. Phoenix 6 2026. And then if you do the pull-down menu, you can pick the latest version. So there's a 26000 and a 26.1. 26.1 is bigger than 26.0, so you pick that one. Bigger number, better. Then you can click Update Firmware. When I didn't choose 2026 in the version, it was like, OK, so show me the version you want me to send. So you could download custom firmware and upload it that way. OK, and if you click back on devices now, OK, I think we're all good. On the top left, there's a back arrow that you can click to go back to devices. And our pigeon is now green. That's great. We have... Hold on. You guys all let me do this. I hold you all responsible. Go back into your pigeon. Remember when I said our drive stuff was going to be 1 through 8, but it's not. It's 3 things per corner, so we need 12 spots for our drive because the CAN coder. So our drive is going to be 1 through 12. Our pigeon has to be at least 13. Who's superstitious? I'm fine with 13. You could do 15. You could skip around. You can put whatever you want. All right, and then we go back. Cool. Now, the thing that reminded me of my mistake is this. Do you want to click on 12 more devices and select the firmware and click Update individually? I don't really want to. Yeah. So what we're going to do is go in there. We're going to set all our IDs and names, and then we're going to use the magic Update All button, because that sounds easier. Let's click on. Let's do the CAN coders first. I think they're less confusing, more straightforward. Click on your CAN coder. And now this is great. There are 4 devices with this ID. A firmware update is available. We have 4 CAN coders. That's great. Hopefully yours says 4 too, and they're all reading in. We got to give them all IDs now. Now it's your turn to figure out your numbering scheme. I've been told by a number of people and convinced that about 4 different ways are all the right way to do this. Way number 1, you do all 4 drive motors as 1, 2, 3, 4. Then you do all 4 steering motors as 5, 6, 7, 8, or as 10, 11, 12, 13. Then you do all 4 CAN coders as the next set of 4 numbers. Way number 2, you do module specific stuff. So front left module is drive steer CAN coder as 1, 2, 3. Back left swerve module is drive steer CAN coder as 4, 5, 6. Or you can do 1 through 3, 11 through 13, 21 through 23, so you have them in completely different areas. Your choice. I'm going to do module based, and I'm just going to go in order. So I'm going to do 1, 2, 3 is probably going to be my front left because we read left to right. So I'm going to start with the left one. I'm going to go clockwise around the robot. So back left is going to be 4, 5, 6, and so on. And I'm going to always do the same order on my things. I'm always going to do, let's say, power, drive power, then drive steering, then CAN coder. So that means CAN coder is going to be number 3, number 6, number 9, or number 12, depending on which module it is. But again, pick the numbers that make sense in your head. OK, we have 4 devices. We don't know which CAN coder we're programming right now or IDing right now. Click that blink button. Which one is blinking? Ah. OK, so we're going to have to guess first. And then we can come back and we can adjust it. So we can guess, and then juggle them around. Or probably the smartest thing to do is put them all somewhere else. And then we can come back through and figure out which one's which. So I'm going to start at 30. We'll just set it at 30 for a second. And then we're going to change the name here in a second. So go ahead and set it to 30. And then go back. And then on this main screen, the devices screen, you have ID 0 and ID 30. We can now click here to see which one is blinking. I've put my robot in an unfortunate location.
I'll help you. You're blanking it?
Yeah.
It'll be this one then, because this guy. It's this one. Back left? Back left.
Yep. Yeah, so you should have like an orange-green fast blink. So after you figure out which one it is it front left, front right, back right, hop back into that CAN coder. Mine was back left, so that means it's going to be 6 in my numbering scheme. You use your numbering scheme. Now here's the cool part. If your numbering scheme doesn't make sense, English still will. So when we put the name here, instead of just calling it CAN coder, I'm going to call it back left CAN coder. Or you could even type the whole thing out, back left CAN coder. If yours is front right, whatever one you found, do front right, back left, whatever it is. Now the name is there. So later, when we go into the Swerve generator, and it's going to be like, tell me what CAN coder is associated with the Swerve module, you don't even have to think. You don't have to be like 1, 2, 3, 4, 7. You just know. All right, click set. Then we go back. Then we do it again. So back left CAN coder is now set. Click on your stack of CAN coders at ID 0. Change it to whatever. We'll change it to like 30. We don't have to go back to the other screen this time. That was kind of a waste. Oh. It said something might still be there, but I think we already changed it, so I think it was OK. But if you get this, you can always just pick a different number to be safe. And then basically, after you change it to a number that's not being used, you can blink it. That one I can see. It's front right for me. Oh. Oh. My front right module stayed front right. Front, and I'm doing the whole typing out this time. Front right CAN coder. Excellent. We're going to set it. And so front right for me is going to be the last. So front. Actually, I'm going to do front left, front right, back right. That's the way my brain works. But again, you number yours the way you want to number yours. So 3, 6, this is going to be 9 for me. Go back. And I want you to repeat this process again for all 4 can coders. Find all 4 of your can coders, get them all on a unique ID. And you can really, when you're just setting it randomly, you can do any ID just to get it out of the way. This is my back right, so that is my last one, gonna be 12. And then I think I didn't hit set. Oh. I don't know. I'm going to figure out where this one is now. This one is front right. So what did I call front right? Remember when I got super excited and said, man, I figured it out? This is back right. I think. Wait, let me blink it one more time. Yeah, that's back right.
I'm like 90% sure it's back left.
I can see it.
No, this one's just blinking regularly.
Oh.
I'm pretty sure it's this one. The one that doesn't have the LED. I think it's back left.
Let me see. Let's Okay, let's see. This one is, in fact,
Blink it.
I,
Keep spamming the button.
yep.
Or no, blink it. Just keep blinking more. Get rid of that duplicate first. So just like set that one to another ID.
This one?
The ID 01. So that way you have 4 game coders.
All right, we're just gonna, I don't know, make it a random number.
You gotta do 0 to 53. So like 50 words.
I think, yeah, okay. So 50 is, don't go over 50.
Now, okay, now you have 4. Now let's
All
pick
right.
one. Okay, that one is back right.
So back right is good. Back right should be 12, and I don't have one on 12 right now, so I can set my back right to 12, and the name is correct. Excellent. Let's try the new 0.
That is front left.
Okay, this one is going to be front left, so that's 3. All right, and then, wait. I forgot to click set. It happens sometimes. Okay, let's try this one to see if this one is really what we think it is.
Which one is, I'm playing that one's back
Okay,
left.
and then let's see. So one of my LEDs doesn't work, so that's where my
Okay, which one's that?
extra thing is.
That's front right.
This is front right. Okay, so this one is front right. Front right is going to be 9.
See, now they're going to be sad because now you have 2 9s.
I know, but it's totally this one. It's going to be back left. It should be 6. Now we're going to find out if I was right.
No, that's front right now.
Orange is fine. That just means it's like not perfectly aligned with the magnet.
All right, I'm going to set this one off to the side.
If it's red,
I had to turn this one off of 9 first. So this one should be back
yeah. So on the
left.
thing, you can see it's just like dim. It's
And it appears to, in fact, be back left.
That does look right.
And then I can take my front right one now and put it back to its correct spot, which is 9, which is, you got to press the 9 button on the keyboard. All right, and then do it still blink as expected? It does. Okay, so
That's all we can get.
my 4 are set up. Sometimes it does help too. You can set all 4 of them just to random numbers, just so they're all different numbers. Like you do 30, 31, 32, 33, and then it doesn't, you know, it doesn't get mixed up.
The names are really what matters.
All right, how's everybody doing on getting 4 can coders separate and ID'd and named? We're getting there. And I do think probably the smarter way to do this, and we'll try it with the motors, is we're just going to put all of them on unused IDs and then dial them back in one at a time, because I got 2 of mine flipped, and then once you have one on the wrong number, you got to change it to a different number before you put the new one to that number, and then the whole thing just goes around in circles. Okay, I think it makes sense. I know some teams are still flipping some things around. We're going to be doing the same thing for our drive and steering motors, but here's something we want to do to make our life easier for these motors. You can look at the motor. You can follow the gears that are connected to the gears that are connected to the gears to know whether it is a drive motor or a steering motor. But that is potentially mistake prone. So instead, what we want to do is we want to find something that you can use to prop your robot up in the air so the wheels are up in the air. I think there's a lot of 2x4s that got maybe passed out. I don't know if everybody got those. And what you want to do is you're going to want to pick up your robot, find some place. It's got like the belly pan in the middle. So I would probably put the 2 beams to the inside, because we're going to need to access the outside of the Swerve modules eventually. So you do not want these to the outside of your Swerve modules.
Make sure your wheels can spin freely.
That's,
They don't hit me. They are supposed to be stiff. That's fine.
we definitely tipped down a little bit on ours, but that's okay. So you want to make sure that you can rotate your wheel, and you want to make sure that you can roll the wheel like it was spinning. All right, and a big thing now, like we kind of tidied up our wires a little bit, but make sure your wire, there's no wires where the wheels are going to rotate or where they're going to spin, that the wires cannot get into the gearboxes or any of that kind of stuff. Now, you want to find out if a motor is your steering motor or your drive motor. Make the wheel rotate like a normal wheel, not spin to different angles, but have the wheel roll like it was driving. If you reach under there and you roll that wheel, the motor that's spinning is your drive motor. Now, if you rotate it so that the wheel was turning in angle, like steering the wheel, both motors are going to move a little bit. You can tell, actually, one of them is moving more, but that's not a good way to tell. So basically, roll the wheel like you were driving. The motor that spins is your power motor. The other one is your steering motor. All right, and we want to go through, we want to ID and name all 8 of our motors. Okay, so I'm going to go into my stack of Kraken motors here. And like I said, I think we're just going to do random starting numbers. So I'm going to do like 40. Set it. I'm going to go back. Oops, that was the 41. Go back to the stack of 0 down here. 41. Set it. Go back. All right, 41, let's go back to the stack, and we go 42. Yeah, there are some on the. Well, here. You have this option, or this option.
You gotta bend some.
All right. Guess we have to bend something out of the Swerve module. That's, you know. I'll go over there and find out what's going on later. Did I say this one's supposed to be 42? I'm already lost. All right, make it 42. Let's go back. I got 41 and 42 and 40. Cool. So back to the stack. We're on 43 now. 43. Set it up. Go back. Go to the stack. 44. Back to the stack of ID zeros. Let's get us a 45. So back again, let's go 46. Back again. Let's go 47. Was that it? Was that the last one? That was, in fact, the last one. All right, then it's the same process, right? We're going to hit the blink button. You'll see which motor is blinking. I can't see. It also beeps, by the way, which kind of helps direct you to the right corner if you're anywhere near your robot. Okay, so mine is, I'll go over, I see which motor it was. I'm gonna roll the wheel on that one to see if it's the driver's steering wheel. And it is definitely the steering motor. So that's my back right steering motor. So this is back right steer and back right steer. So it's going to be drive, steer, camcoder. So for me, my steering motors are 2, 5, 8, and 11. So this is going to be 11. And again, this is why you put the name in, so you don't have to like figure that stuff out every single time. And we go back and pick the next motor. Blink it up.
Before you have them move on to firmware updating, probably.
All right, this one is blinking on the back right as well. And since I already did one back right, this has to be the other motor. So this has got to be back right and our drive motor. And you can call it drive, you can call it power, or whatever makes you happy. Back right drive then is going to have to be, so it's 10, 11, and 12. So it's going to be 10. We'll set that up. All right, going back. Let's pick the next one. Sure, 42. Let's blink it. I can see that one. That is on the front right. And if I rotate that wheel, it is in fact the motor that is spinning. Yes. Well, it's kind of tight. Wonder if there's some braking going on that one. Dynamic braking. All right, so that's front right. Wait, I forgot already. Drive, front right drive? Yes, front right drive. Okay. So it is front right drive. Cool. Front right drive is going to be 1, 2, 3, 4, 5, 6, 7. Let's set it. Let's go back. Oops, did not mean to click on whatever I clicked on. Find the next in the 40s. Make it blink. Okay, that's on the front left. Is that a drive motor or a steering motor? That's the drive motor. So front left drive is number 1. Front left drive, set and set, go back. Find the next 40, 44, blink it. And that is front left, and that's gotta be the steering motor. I can see it blinking from my seat for once. Front left steer is gonna be number 2, set these both. Find the next in the 40s, we got 45, blink it. I can see that that's front right is blinking there, and that is steer, so front right steer, unchanged. What number is that gonna be? 1, 2, 3, 4, 5, 6, 7, that's gonna be 8. Set it to 8, then we go back. Blink this one. Okay, this is an inverted one on the back left. And if I spin the wheel, that is definitely the drive one. So this is back left drive. And that should be ID 1, 2, 3, 4, 5. Set them, set them. And I could process of elimination my last one, but you don't want to do that. You still want to blink it and test it because this is another check. If it duplicates something you did before, then hey, you know you got a problem. Wait, I feel like is that the one I just, okay, that's the back left. Hopefully this is the steering motor and I didn't get confused. Oh no, this is definitely drive. The other one was steering. So see, that's why you do it that way. All right, so this is actually back left drive. That's correct. So I'm gonna set this and set this. I can't change the ID yet because I put the other one on that ID, right? So back left drive should be number 4. We can also look for the one that I named back left drive. Back left drive. One, two, three, 4. Huh. So this one is back left steer. I called it drive. Also, by the way, if your name changes, sometimes the ID doesn't update, and I think that confused me. Let's set these. I'm going to check this one. Actually, so back left steer device ID 5. Let me blink that one again and make sure. Yeah, that is correct. And then now I can go to my last one, which is back left drive, which should be number 4. Set it to that, and we go back. And that is all of our devices set. And now we just got to get everybody else caught up to this point.
Okay, so that's steering motor. Back right. Left right steering motor.
So I cut some corners with my robot. I forgot on your steering motor, so the rolling the wheel is probably less necessary for you. How are we doing? Okay, good. A couple still working on it? I think we're going to do like another final check of this before we go into the swerve generator. And then in the swerve generator, we're going to kind of get another check. But this, I think, is the trickiest part. If you get all of this stuff set up right, we're set for success. But let's get our update going. So you can click this checkbox here, the double check mark, to select every device. Incidentally, if you only want a specific type of device, let's say your CAN coders are working and you don't want to touch them, but your motors need new firmware, you can select one of the Krakens and select the check marks. That will now only select all of the Krakens, so you can do it by type. Or you can, not select anything and everything gets selected. That's kind of what we want here. We just want to update everything to the latest version because there's no reason not to. So do that check mark and then click the Update Selected Devices button. And for all of them, make sure you're Phoenix 6 2026 and just click Update to Latest and it'll do everything for you. This might take a couple minutes. That's fine. You should double check too. Like make sure it's updating 13 devices, which I think is what we have. 12, 3 per module to get to 12, and the pigeon for 13. And that should be right here. Did anyone finish before me? Man, want to trade computers? That helps. Yep. All right, how are we doing? Is everybody's done updating, or is this some still running? Looking good? I guess if everybody finishes at about the same time, it is probably the communication speed, not the computer speed. All right, close that. Now, the other thing I want to show you is these arrows. This gives us a sort by. You can sort by ascending or descending. I think just a sort by ascending. ID. And now it goes 1, 2, 3, 4, 5, 6, 7, 8, etc. Now I think is a good time. I'm going to make you do this one more time just because now that they're in order, we're not jumping around and saying, okay, this was the back right, now we're at the front left, and this is this thing. Go through it one more time, blink stuff, go around the robot, and confirm everything is where you think it should be. Okay, so now that we can click this sort by up here, and it gives us the option of ascending or descending, and you can choose the sort by, so you can do ID or CAN bus, model, so you can get like all of a specific device type together, but we want to do ID, and we want to do ascending, and the idea now is all of our devices are in order, 1, 2, 3, 4, 5, 6, and it's good, right? I can see drive, steer, CAN coder, drive, steer, CAN coder, drive, steer, CAN coder. But what I want to do now that they're in order and I'm not jumping from corner to corner is go through and blink them all in order and make sure that it works. So I'm gonna blink number 1, and I should see that on the front left blinking. And then The next one also front left. The other motor's blinking. Now the can coder on the front left should blink. I missed the blink button. Yep, and then we can go to the back and continue. Back motor is blinking. Yep, steer is blinking. Yep, can coder is blinking. No, because that LED's burned out, but I know it's the right one. Then we go to the front right. Yep. Yep. And yep. And then the back left. Yes. Yes, and in fact, yes. So mine do look good. All right, I think everybody's looked good. We're happy with our IDs? Okay, now we're ready to do the other stuff. Click on your 3-line menu. The hamburger menu, I don't know. I mean, I guess that makes sense. I like the 3 lines and the 3 dots. We're gonna go to mechanisms. And we're gonna do swerve. Now, on the swerve mechanism thing here, it's saying a few things. Pre-check. First, you gotta have these things if you want to do a swerve. Gotta have at least 8 Talon FX or Talon FXSs. We do. All of our motors on the swerve are Talon FXs. We gotta have at least a pigeon. Does anybody actually do this with 2 or 3 pigeons? Pigeon 2.0. Pigeon 2.0. Oh. The greater than or equal to is the version number, not the number of them. I kind of want to put like 3 on there, and then isn't that like because the NASA, the guidance computers, they had 3 and 2 had to agree, or it wouldn't do the thing. So, all right, you can have Phoenix Pro. You don't need it. You must be on 2026 version because this is the 2026 version of Tuner X. Confirm that there are 4 connected encoders. You can use whatever kinds you want as long as you have 4. Check the box. Say yes. We do. We have 4 can coders. All right, wheel radius. Radius, not diameter. You could get some calipers out or a tape measure and try to get the actual specific size of your wheels. They're supposed to be 4 inches, so 2.0 is correct. If you like wear off all of the nubs on your wheel, it's probably not 4 inches anymore. It's probably like 3.8 inches or 3.9 inches. You're going to have bigger problems from the fact that you have slick wheels on carpet than the fact that your wheel diameter is slightly wrong, I think. So at some point, and we talked about this yesterday, but I don't know if I told everybody, right? Watch these treads. I suggest you buy at least 1 more set, but probably a couple more sets of these treads. These are new this year. I haven't seen them run before. The old ones, like, so on my robot, I have like rubber conveyor belt material tread. That wears down faster, I'm guessing, than what you have now. That one, you'd have to replace maybe every event, potentially once during the event, so twice for every event. These ones, I think, will do a little bit better, but you might end up in a situation where you got to change it once or twice during the season. So having those on hand and not having to order them and wait for them to come in is probably a good thing. OK, we need front left to front right distance in inches. Front left to front right distance in inches is not the size of the robot. This is the size of the rotation pivot on the swerve module. So remember that magnetic shaft that we put in the dead center? That's what it rotates around. So that's what we're trying to measure the distance between. Now our front left and front right and back left and back right, same dimension, same distance. So you can try to measure that. It's easier to see it and try to measure it on the inverted swerve ones because it's from the can coder to the can coder. And the cool part is it's really hard to get an exact number, but I believe for the inverted modules from the outside of the robot to the encoder is 2.5 inches. So we could take the entire width of our robot minus 5. That should be correct. But like when I just eyeball the center to the center, the closest number is 25. It looks like I'm a little under 25. I'd say maybe 24 7/8. Because we're bolted into those pre-drilled box tubes, the hole spacing is every 1/2 inch. So we know if it's close to 25, it's 25. And we are, in fact, 25. Okay. Then it's asking what is the distance from our front left to our back left. So what's the distance from the front to the back of our robot? And once again, we have that extra 1-inch bumper mount on the front of our robot, and the extra don't let the intake roller smash the motor mount. So we don't count that. It's, again, from encoder to encoder. Our robot, I think, is 24 inches, not counting the thing. So if we subtract the 5, it should be about 19. And I see 19 on my tape measure. So I'm going to believe 19 is probably the correct answer. How come when I press enter, it doesn't clear the selection? It's fine. The number's in there. It's good. Just got to click on something else. All right. Next, we're going to pick our module manufacturer. Our modules are West Coast products. But of course, if you're not in the building and I'm talking to you on the video later, pick whatever yours is. The type is going to be Swerve X2, X2i, X2t, X2c. We actually have 2 of the 4 on our robot, so that's cool. The ratio. Y'all remember your ratios, right? Did I save it? I did not. Oh, no. I'm not on the internet. OK, I can switch to the internet and double check. But I believe we are X2. So you go to the X2 and you pick the number of teeth you used for the drive motor. Remember, all the steering motors were 10. Your drive motors were 11 or 12. Mine, I think, is an X3 10-tooth, because I did not get mine the same time you got yours. But let me, I'm going to pop over onto the internets, and I'm going to load up that chart just so we can see it. Or there we go. All right, yeah, so we used the 16-tooth, which put us in the X2 ratio. And then, yeah, you had 10, 11, or 12. And if you remember your numbers, 12 is the fastest. 11 is the slowest of the choices you had. If you did 11, you're almost the same. You're slightly faster than my X3 10-tooth. All right. We would now like to click the New Project button. Not all project settings have been completed. Oh, wait. Turns out just because it said 2 doesn't mean that it's actually in there. So make sure you click on the 2 box and the wheel radius box and type it in. Then click New Project. OK, did everybody make it to the screen before we? Yep, good. OK. So now we're going to configure all of our modules. So our first module that we're going to configure is front left. So what we're going to do now is go through the pull down. There is a blinky thing here, so you could like quadruple check at this point that it's the right one. But basically, turning motor for left front. This is why we named them. Front left steer. Drive motor for front left. Front left drive. By the way, you see my device IDs here? And you might notice that they are incorrect. So front left drive should be 1. Front left steer should be 2. And front left, well, just pick can coder. And then front left can coder should be 3. Turns out when you change the name, if you've had the devices named already and the name's saved, the device number is part of the name, and I did not type the new name in. So basically on these screens, forget my device ID. The name is the only thing that matters. And then I need to go back to my robot connection, I think, to make the other thing pop up. So let's get back on that 999 demo. I feel like the wireless network takes longer to connect when I'm presenting. Hey. So if you run into the problem I had, which is I was not connected to the robot, just switching modules and switching back, now I can actually select my camcorder. Should be front left. All right, and we're going to now validate our selection. Here's the thing. Warning. Stuff's going to happen. Things are going to move. Don't put your fingers in the things that are moving. Technically, you should probably safety glasses up for robots turning on and being under power. OK, the validate azimuth motor plus encoder. We're going to basically give voltage to the azimuth to verify that the encoder and the Talent FX share the same module. What does that mean? It's going to try to rotate the wheels. It's going to try to steer your wheels and see if the encoder that you said should see the wheel moving sees it moving to see if they match. So when we do the start azimuth test, in theory, the front left the motor should just go around and around and around and around steering-wise. Make sure that's clear. Make sure that you are ready for that to happen. OK, our second test is going to be then we're going to make the wheel spin and make sure that it's driving forward, the motor that we expect to drive forward. When you click on this, it's going to say, hey, you got to enable the driver station. The driver station is still the controller of whether the robot can move or not. So if you go to your driver station, which should still be open, you'll note that we are in teleoperated disabled right now. Go ahead and click enable. You get like a different flash pattern on your light, and on that light also is on your RoboRio. Then you can click continue, and you want to now watch to see if your front left module is moving, is rotating, essentially. I don't know how to figure out the right word for like the wheel is spinning because you're driving and the module is spinning because it's rotating. If you get a check and it was the front left that moved, because you could have a mistake here where you have the camcorder and the steering motor both together but in the wrong place. If the front left moved and this gives you the check, you're good to go. Then move on to the drive test. Hit that one. Enable. Make sure you're still enabled. You should, again, see the front left motor spinning, driving. I can see mine. You can take my word for it. And we get the green check mark. When you got both green check marks, just validation completed. When this screen is all green, when you got green check marks everywhere, go ahead and click on front right. Do the same thing. Turning motor, front right steer, drive motor, front right drive, encoder, camcoder, and camcoder. Oh, wait. Yeah, front right. Validate. Go. And in fact, it is spinning, but we let the test finish so it gets a check mark. Start the drive test. Continue. Ah, yeah. Front right is spinning. We'll let that finish, and then we're done with the front right module. We're going to continue to do the same things for back left and, in fact, back right. Validation completed. Let's go to back left. Let's choose back left steer, back left drive, can-coder, back left can-coder. Validate that selection, start our azimuth test. And I leave it enabled this whole time. But in theory, if you're spending a lot of time on the screen thinking about stuff and checking things, you probably should disable and then come back to it. But I'm just running right through the test. This one looked correct. Let's do the drive test. I like it. And I'm ready. Validation complete. Let's go back right steer, back right drive, can-coder, back right can-coder, validate, go azimuth go. We looking good? Start drive test, and we're looking good. Let that finish. And validation complete.
So,
Yes.
if all of these are perfect, what do we just wait?
All of these are perfect. Just gotta like.
And you can tell, like, if the wiring wasn't, you could have all kinds of problems, right? And this is like the biggest problem. But now that all that is good, that's a yeah. Well, good thing you already passed this one.
But you'll wanna. It's using. Is your robot turned off?
I
Disable?
oh, we're good.
Let's use this one.
Oh wait, I think it's inside.
Yeah.
You're right. Yes. Double
Yeah,
the
I'm
inside
good.
because then otherwise it's not flush with the ruler.
Yeah.
Yes, you need to
I
see
went
it
through this
instead.
with like Omar like 50 times of figuring this out.
Yep.
The best way
Yep.
to choose how to do it, and we came to this
I think I remember now. I'm good.
because it was flush with the ruler, and it was very obvious if it was incorrect. Everyone was like, "Well, it doesn't matter." Well,
As we are finished. The next step is eventually going to want us to try to align the wheels to get them straight. So if you have the metal pieces, uncut metal pieces that you gave out with the kit, that's going to work. Got a giant ruler that also works. Basically any piece of metal that's longer than the wheelbase, then the short side of the wheelbase is going to work. So actually if we had to, some of our 28-inch ones from the table that weren't used are probably okay too.
Alright, so unbag one of those bad boys. Okay. Is everybody still alive down there? Or did they get dumped in the snow now? I don't live here, so go for it.
Oh, we're taking it off the wood?
All right, are we looking good? Is everybody all green on this screen? All right. Okay, so we're going to move on. And like I said, the next thing you're going to want to grab is we need a straight edge. So a random piece of metal, 1x1 box, 1x2 box, whatever you got that is long enough to make it from one wheel module to the other from front to back, which is about 24 inches, about 2 feet. It's going to be good. All right, verify that your selected gyro is the pigeon too, because, you know, that's the only one plugged in. That's the only one that sees. It should always be there. But if that's blank, that could be a problem. Could mean your pigeon is not reading in. Though we would have noticed that earlier when we were setting IDs. So I don't know. All right, we're going to click on the Calibrate Encoders button. All right. Let's disable the robot first, because it's telling me to, and I probably should have already. So disable your robots. All right, and there's basically, you can probably follow the instructions on screen and get all you need to know. But we want to disable the robot because we're going to start doing stuff. Then we're going to hit next. Next thing is, we can rotate the modules now by hand. Here's what I need you to do. I need you to make it so the wheels are pointing forward and backwards. So if the wheels rolled, the robot would drive forwards or backwards. So wheels straight along the sides. And not just straight along the sides, but in fact, there is a bevel gear on that wheel, right? The bevel gears all need to be pointing towards the inside. So front left bevel gear and front right bevel gear pointing at each other, back left bevel gear, back right bevel gear pointing at each other. So we're just rotate these again. I think if you get down on the side, you can really see the bevel gear. Just make sure they're on the inside of the robot, and that looks good.
You can always determine a position from a velocity. Because so if we know how far we're going or how fast we're rotating, we know the angle of the robot from how fast we're rotating. And all of that breaks down into a lot of math that kind of feeds us. But the goal of the generator is so you don't need to necessarily care about it. And it will go angry.
Okay. I think everybody's got that. Let's go to the next step. Now we want to make sure our modules are lined up as straight as possible. So take that straight edge and hold it against the wheels. If it's flat on both wheels, the wheels are lined up. If one wheel's rotated a little bit, you'll notice that. Did you do yours already? Can I borrow yours? Thank you. All right, so just in from the side. And basically, if you grab the wheels and the box at the same time and wiggle a little bit, you can get it to sit flat. It's pretty straightforward. I know it's going to be pretty much impossible to see underneath the bumpers, but just squeeze that in there. Those wheels are flat, and we are now as aligned as we can be. Now, this alignment, the better you do with this alignment, the better your robot is going to behave over long periods of time. You won't necessarily notice it if you're off by a little bit and you're just driving around a little bit. But if you imagine, like, if you did it so your wheels were both a little bit turned, when you tell the robot to drive straight, it's going to not drive straight. It's going to drive a little bit off to the side, which, you know, if you're off by a degree, might not be noticeable. But over time, that error could potentially add up to something. So you definitely want to take your time to do this right. If you notice your robot is ever really not, like, you go straight and it really feels not straight to you, you can always go back and repeat this process to get new values. And you won't have to, you can just take the new values for that and put it in if you need to. All right, click next again. Yes, and then we're going to now click Calibrate Encoder. And the robot doesn't have to turn on. So basically what it's doing right now is it's saying, OK, So the encoder basically measures the angle of that center shaft, which basically measures the angle of the wheel. It's saying, okay, what value am I reading right now? Am I reading like, whatever, 157? If it's reading 157, then it's going to say, cool, front left module 157 is straightforward, straight backwards. Back right module, what am I reading right now? 400. Cool. Back right module 400 is straightforward and backwards. It's saving all those numbers basically as an offset so that it can make that translation in code when we get there later. All right, go ahead and click I'm finished. If you have successfully configured offsets for encoders, click I'm finished. And then we're going to continue to verification. OK. Again, there are some things here to warn you. Make sure it's on blocks. Make sure your modules can spin and rotate freely. We're going to use the driver station. It won't work without the driver station. And apparently, it's not skippable because, I don't know, they don't trust us. Dalton, who worked on this software, is sitting in the back shaking his head and saying that he does not, in fact, trust me. All right, let's generate. Let's verify steer. Number one, we're going to prepare the robot. That's all. This is all normal. There's a note here on the driver station. Look, if bad things happen when you're driving your robot at any time, know that the Enter key on your keyboard disables the robot, and the spacebar key on your keyboard e-stops the robot. Both of them will make it stop moving immediately. The difference is, if you e-stop the robot, I think you have to reboot the robot and potentially the driver station, both, to clear the e-stop. I think just the robot. OK, just the robot, I'm being told. So spacebar is more annoying because you got to wait for the reboot afterwards. But at the same time, if your robot's crashing into stuff, the spacebar is kind of easy to slap. So, keep that in mind. All right, so we are going to, OK. So step 3 says you can place the robot such that the module is not making contact with the floor and ensure the modules can rotate. That's what we want. We're going to run this. And basically what we're looking for is we're looking at the wheels and how they're spinning. So go ahead and click Start. And make sure you enable the driver station, too. And then because I didn't enable the driver station, mine didn't move. If yours is the same, you can rerun the test, and it'll do it again. Start. So when I clicked Enable, it was selecting the driver station, not selecting Enable. So let's rerun the test a third time. And when you click it, you're going to look from the top of the robot. And what you want to see is every single module should be rotating counterclockwise. We want them to rotate counterclockwise. So if your modules are running counterclockwise, good job. If your modules are running clockwise, oops. So get all your tools back out. Or just check the little inverted box. I think all of mine need to be inverted, which is absolutely not what I expected, but that's cool. Wait, is it what I expected? It's weird because the inverted modules have an extra idler gear, so I would have thought they would be different, but maybe there's an extra idler gear. I'm so confused. Anyway, now that I've inverted everything, I'm going to rerun the test again. I got to get better at enabling the robot. Ain't no way. Ain't no way. All right, well, empirically, mine all need to be inverted. You should verify after you do the check marks. You should run your test again and make sure yours are good. So it's like, did all modules rotate counterclockwise as seen from the top of the robot? If so, click yes. Otherwise, try it again. Mine are now good. I'm clicking yes. Anybody here still need help or have it not working right? Can we? Nope. Did they go the right way?
Yeah.
No.
Well, after we did inverted.
Okay. So we have to. There's just enough room. We're good. You're good. It is yesed up. You should see the green steer test pass dot. You can't, but that did read the yes, I think. And I think if you hit back, we are now good.
Okay.
That's
Is it magnified in?
so weird.
This is clockwise. This is counterclockwise when viewed from above. So we need to see all the wheels, not any of the gears, going this way. Run it again. Run it again.
So what you do?
Yeah, the big gear should be one. Wow.
And then now
Yes, it should be one. Yes, 100% 1 to 1. Like, is there another gear there? That is counterclockwise, that's counterclockwise, that's counterclockwise, that's counterclockwise. Yeah.
Going the same direction as
Okay. It's supposed to be counterclockwise, so you're good now. That's the yes button on the left. You gotta just yeah. Gear test it. How do you unzoom? I don't know. I don't think it's supposed to be like that. I don't think it's supposed to.
Some people will screen, I guess.
Oh, you can change the Windows zoom setting from what you want your to do.
Here, if you want, you can do that real quick. Just,
I think we're looking good. Next up, click the back arrow up here, verification steer. We're going to go back. And now we have to verify drive. Click on that. These things are all the same as what we just had. These things are the same as what we just had. By the way, it's saying this one is if your motors are stall whistling. If you hear the motor like screaming in pain, you should stop and make sure that the motors can turn freely. If the modules are locked up and it's trying to move but it can't move, brushless motors will make this kind of like high-pitched kind of like, it's like a screaming sound. That's what it sounds like to me. And then if your robot is spinning or stuttering, the other thing that might be is swap batteries to a new battery if your battery is low. And you'll see that on your driver station. So I'm at kind of 12.3. That's all right. If this number, while we're sitting here doing nothing, is like 12.0 or less, you for sure need to change your battery. I would probably change it a little sooner. 12.3 is kind of getting to my bottom end of it's probably fine. Charged battery should be reading more like 12.6, 12.7. I think a freshly charged battery could read over 13 for a little bit after you take it off the charger, but that's surface charge, and it'll drop down to that high 12s afterwards pretty quick. All right, for this one, we need to enable the robot, and I'm going to do it this time actually before clicking the button for my robot's enabled. Click Start. And this time we're watching the direction that the wheels are rotating. So the wheels should eventually spin. What it's going to do is steer all the wheels to straight forward. So if you had rotated your wheels, it'll do that for you. And then you're looking to see if your wheels would make your robot drive forward or backwards. So you're basically looking at the bottom where it's touching the carpet. Is it dragging the robot forwards or is it dragging it backwards? The top of the wheel, the direction the top of the wheel is moving is the direction that the robot would be traveling. And mine was going forwards towards the intake. So on this robot, first has decided that the intake side is forward and you launch out the back. And I do think I agree with that. I think that makes the most sense. You're going to spend more time trying to line up intaking. When you go to launch, you kind of park close and stop. And you get an average velocity, which is cool. Did the robot move in the forward direction? If you're really, really not sure which way it's moving, of course, if you're in the building with us, we can tell you. But if you're at home doing this and you're not sure which direction the robot's moving, it creeps forward slowly. So if you put it on the ground and have some space in front and behind the robot, because it might go the way you didn't expect, you can put it on the ground and see which way it moves. Mine did go forward. I'm clicking yes. Test completed. You may return to the previous page. OK, now on this page, we're basically good to go. There are two things we can do to move on from here. We can either generate a project, or we can generate only tuner constants. Generating the project is going to give us the entire robot code. It's going to make that whole folder that we can open up, and the Swerve drive code is already in there and already done. We're going to do that just so we can test these robots, drive them around a little bit, and then we'll come back and do more coding. The other option is, well, I should also say, and then we're going to throw that code away, because that's not what we actually want. The other option is to generate only tuner constants. This will give you a file with just all the constants, offsets for your encoders, directions that motors should be going, inverted, non-inverted, all that stuff is saved. This file you can put into any of the CTR Swerve examples and have your Swerve drive ready to go. So we're going to generate the project. Turns out one of the files in the project is the tuner constants. So when we move to our other project, we're just going to copy that file over. We're not going to have to do this again. So go ahead and click Generate Project. What team number should the project be generated for? I will let you guess what team number the developer of this app was on. Put in your team number. Click OK. What programming language? We're doing Java. But if you're not doing Java, feel free to click the other thing. All right, and then I'm going to do a folder on my desktop. And this is, I don't know, this is our 2026 first Swerve test. And I'm going to go into that folder and choose Select Folder. I think if you highlight the folder, you can click Select Folder too, either way. All right. Successfully generated project. When you get successfully generated project, go ahead and open project in VS Code. And this is going to open. You can also, at this point, close the TunerX software if that worked. You can save this first, I guess, before you close. You can export the project before you're done. And we can have this Tuner Swerve project. You can put it anywhere. I'm just going to throw it on my desktop for now. But this will have all the values too. So if you have to come back and re-edit stuff, you could load this file and keep tinkering with it. And now for sure we can close the software here. This VS Code is the same. Can I make this go away? Is the same WPI Live VS Code that we installed. So if you need to get to your code later, right, you're just going to run this WPI Live 2026 VS Code shortcut. And then if I go back to VS Code, it's saying, OK, we're opening this folder. Do you trust the authors of the files in this folder? We don't have a choice. You have to trust them. And it's you and first and cross the road electronics. So it's probably fine. If you get this, go ahead and say yes to update. It looks like there is now version 2026.2.1 of the WPI Live. If you don't get that, don't worry about it. And you probably want to connect to the internet. I think it's failing because it's got to like reach out and get some things, and I don't really understand what it's doing. But I think if you connect to the internet, it'll be good for your program. And while this is going, I don't have to wait for it to finish. But if you go into SRC, that is source. That's where the code that we care about is. All these other little folders, you pretty much ignore them entirely. Pretty much. If you go into Java, this is our code that was generated for us. So in subsystems, we have our command Swerve drivetrain. Good news is we really don't have to mess with that. Generated is the tuner constants. That's the file where we created stuff. If you click on that, you can kind of see everything that's here. So first of all, in Java, I think everybody here must have done at least a little bit of this Java program before, but we have the imports. These are all the things that are being used. We are using the Phoenix 6 library. That gets included automatically or installed automatically when we use the example or we generate our code from the Swerve generator. So we don't have to do anything with that. But as you scroll down, you're basically going to see. So this first section, these are our, actually the first two are our PID values for steering and drive. We're not going to get super deep into this. If one of your robots goes crazy, we got some experts here who can help you tune it in. But the basic idea is if you have something and you're controlling it programmatically and you want it to get to a specific spot. So we got our wheel, and we want our wheel to go from straight forward to 90 degrees, because our driver's saying, I'm driving forward, now I want to go straight sideways. That wheel has to go from this position to this position. It has to make that 90-degree turn. How does it do that control, right? So one way it could do it is, hey, if I go with some set power, start turning, there's a good chance if we choose a fast power, it gets there quickly, but by the time we tell it to stop, it's gone too far. We can tell it to go real slow, and it will slowly get there, and it'll stop perfectly at 90 degrees, but you had to wait 3 seconds before you could start driving your robot sideways. Also bad. PID stands for proportional integral derivative control. It's, there's some calculus-y things, but basically it's like this. Proportional control says the farther you are away from where you want to go, the faster you should go. Make sense? Right? If we're 100 degrees away, let's go 100 power. Or 100% power. If we're 50 degrees away, let's go 50% power. If we're 2 degrees away, let's go 2% power. That means when you're far away, it's going to go fast. When you get close, it's going to do that slowing down part. Turns out that is also typically not super stable. It'll get you there, it'll get you close, but it usually doesn't get you all the way there, or it's going to oscillate a little bit around your set point. That's what the other two terms do. So you have a derivative term, which sort of says, hey, how fast are you moving? How fast are you approaching the goal? And it might be like, whoa, you're approaching too fast, we need to slow down a little bit. Or you're not approaching fast enough, I'm not going to do anything. And then we have this integral term, which is like, how long has it been since we started trying to get there? Are you really close and you're just not quite getting that last bit? And so this will kind of ramp up and push you the rest of the way. Proportional is the biggest one. There's some other values here as well, which take into account like the voltage and the amperage and stuff like that. Generally speaking, you don't want to touch most of these numbers. If you're going to change stuff, usually changing KP and KD is going to do all the work for you. There's not even any KI on the default settings. I've also found that the default settings pretty much work fine. All right, let's keep going. So we're doing closed loop. We're picking our motors. We're giving them some initial configurations. Doesn't really matter. Everything's got a 60 amp current limit. That's great. You're not going to hit it. If you do hit it, you want to trip out. It's going to protect the motors. Got some logs in some places. Where's the things I'm actually looking for? So this is the kind of free speed. This is kind of like the maximum speed of your robot, 4.76 meters per second. This number should be calculated based on the ratio you chose. So your number should not be my number, because I had the weird ratio. That's not anything you guys had. And then that's the same thing here. We have couple ratio, drive ratio, steer ratio. These numbers are going to be different based on what you chose. Our steer ratio should all be 12:1 because we use the 10-tooth gear everywhere. Do we need to invert any of the motors? That's based on did it drive forward, did it drive backwards? Do we need to invert the steering would be whatever that we did. So all of these things in here, like what is the motor ID? 1, 2, 3, right? The way we set it up. That's all saved into here for us. What is the position to be in 0, right? My front left one has to be off by negative 0.475 to be centered. So all these numbers are what we set up in the Swerve generator. If something is a little bit off, you could go in here and edit it, or you could go back to the Swerve generator, get new constants, and you can either open the constants file, paste it in here, replacing everything that's in here, or you can copy the tunerconstants.java file to the folder where that file exists on your hard drive and overwrite it, and now you have your new constants. All right, what I want you to do, though, is I want you to connect to your robot, not the internet. We needed the internet, so it built nicely. Now we're going back to your robot. I should have said that 10 seconds ago while I was still talking, so it would be connected to the robot now, so I can move on to the next step without telling you this story to waste the time while I wait for it to connect. And then go ahead and click on the WPI lib icon right here. And what we want to do is just deploy our robot code. So if you don't see it as an option, start typing deploy. It's going to show up. When you see it, you can click on it. Or Shift 5 is the keyboard shortcut when you're doing this a lot. While this is deploying, I would like for you to grab your gamepad and plug it in.
Do you want to lower the speed first? Or do that after this? Do it after. Okay.
And we're going to do a bench test here to make sure that like forward goes forward, left goes left, right goes right, backwards goes backwards, diagonally forwards goes diagonally forwards, etc., so on and so forth. And then after we do that, the very next thing we're going to do is limit your max speed so that nobody dies today. The field is included in the as a somebody, by the way.
Yes, at some point.
All right, on the driver station now. If yours finished building, go ahead and go to the USB port area. If you plugged in the gamepad, make sure it is listed as gamepad 0. That is the default, I believe, for the drivetrain. Mine was not. I just dragged it up. Then we're going to go teleoperated, and we're going to enable, I think. Kind of scary. Disable it. Here's the good news. I think that's fine. Here's what's happening. The robot is up in the air. So when you're trying to steer, if there's no weight on the wheels, it's going to twitch. It's going to move much easier, right? When we put the weight down on it, it needs more power to turn. So we're calibrated, I think, for when you're on the carpet with some weight. So right now, it's going to do a little bit of that. And that's the oscillation I was talking about. That's overshooting left and right. That's fine. We're going to enable. When you enable, we're going to do a couple tests. I want you to gently push forward on the joysticks and see if, oh, wait. We're going to, first thing that I want you to do is press the left bumper. That's the top button on the left side. What this button does is it resets your, basically, knowledge of where the field is. This robot is set as field-centric, which means when we push away from you, it's always going to drive away from you. When you push towards you, it's always going to drive towards you, depending on how you started up on the field. Now, when you press the button, that resets what that position is. So you can see if forward goes forward, if backwards goes backwards, and then you can go sideways on that same gamepad, and your module should steer sideways. And left, you should steer and then have the wheels rotating to the left. Right should steer over and have the wheels rotating to the right. Diagonally should do the diagonals. And then the right joystick, if you go left and right on the right-hand joystick, that should go into spinning mode. So the wheels should kind of go 45 degrees and spin in place. Clockwise and counterclockwise. And you can double check that clockwise and counterclockwise are clockwise and counterclockwise. So give that a quick test. When you think everything is good, we're going to go back to the code and make our little speed limiter adjustment. All right, is anybody's not doing what we want, what you would expect? All right, if you need help, yeah, definitely let's get somebody over there and we'll get troubleshooting.
Okay. On your left joystick, point left. Point left and hold it. You're browned out or you have a flaky wire? You browned out. I can tell because your radio notes that the radio is starting to front power. Turn it off and replace it. But from my brief look, it looks fine. Once it comes deployed, you don't have to redeploy it or anything. You're basically good to go on the driver's station. Okay, let's take a look here. Okay. Yes. Okay. Go ahead and enable run. Okay, point on the left joystick, point to the left. Hold it. Can I see a joystick? Yeah. Well, no, left and right and forward and back. Okay, that's good. No, I think it was just oscillating really bad.
Oh, their battery's dead.
Oh, okay. Your battery's dead.
Yeah.
But that should...
Change the battery and let's see what happens when we put it on the floor. Because that's next, and then we'll know for sure.
Okay. Go ahead and sit. You're good. Okay, it actually doesn't fit. I thought it was more gentle on it. I thought it'd be more gentle.
Yeah. That's like way low for the battery. You want it to, you want to change it like 12.0 at a minimum.
What did you do?
Yep. Yeah, so the battery, so what's going on is battery is super weak. It's not able to produce the power, the supply power that the motors are demanding.
Can you disable for a second the robot?
Try in different directions.
I think there's something smart in there. I was able to like work it a little bit. But this is fun when you did it before you spun it.
That's what happens.
We can try. So
All right, If you can jump on your computer. Even if you're having some issues, we're going to keep working on those issues, but we can all make this code change and get it deploying while we're working on that. If you could go to robot container. So in our code here, we have tuner constants that we're kind of looking at, but we also have this robot container.java. If you click on that, a lot of stuff in here is auto-generated. We're not going to worry about it right now. But basically, the first line underneath public class robot container should be line 23 for everybody if you haven't edited stuff. This is saying private double max speed equals 1 times the tuner constants that we calculated in meters per second. So this is basically saying that is the maximum speed that the wheels are going to try to spin. So that's the maximum speed your robot can go. We're multiplying by 1.0 right now. We can change that to any number we want. Let's try 0.35. Let's say 35% is the new 100. Now remember, when you go home and you want to go faster, you got to change that number again later. OK, so you can save the program. I think it saves when you deploy, but then just go ahead and deploy the robot code again. When this one is done deploying, what you can do is try your robot on the field. You can take if you take your laptop over to one of the driver stations, you could set it there. But if you can see from your table, that's fine too. I need to say before we start doing this, I think we still have at least 6 teams left. Make sure you're aware as the driver of who's going on and off the field, and make sure as somebody taking your robot on and off the field, you're aware of other robots that might be, moving. So there's going to be lots of movement. We're not going to do like a hard stop. Now you can put your robot on the field, but take your time, be safe. And if it drives fast, you can still only push the joystick forward a little bit.
should probably zip tie that down so it doesn't fly out again.
Yeah.
Don't Beyblade it. How about you just don't Beyblade it?
Did you unlock your car, Steve?
It's all good though. You're fine.
Are you still disabled?
Yeah.
Somebody else.
Well, guess what? Guess what the kid behind me did? He knocked off the radio. Right before we decided. Perfect.
It doesn't matter. I went over the short way and it still got caught. Yeah. Thank you, Max.
Fifth time. The fifth time you've done this.
Don't do it again. I don't want to come retrieve it.
That man over there, not you, get out. The man behind you. He beat that robot 7 times. He beat it. Be nice to Bubba. I don't care. You're just a Bubba. I only know his president did.
It's getting shipped up. Oh my goodness.
Well, do it. What?
No, if you need to turn it up again, you know how. And you'll will for real events. Loud noise. I did put that bar there once.
That's good, Nick.
Oh, you're using the red one. Oh. 1-0. Yeah, no, I found that out this year.
Times. 8 times.
That is like that are What? Maybe.
Don't worry, the circle will help you.
I'm literally so running already.
There's a robot right here.
Well,
It might brown out like immediately, but
not trying to have the humans on the field.
nope. Oh, that's right. They're out there. Right there.
How about you?
Robots and humans are different.
Robots
But
versus
then
robots.
that,
You're segregating women?
Wow.
Why do you think so homophobic? Why do you think
You're scared that I have to go in.
Yeah, you can go.
If I need to.
Little bar right here.
Why you
So you
just
just do this and you lift it up. You see, there's like a bar in here. Don't push there.
Do it again. Do it again then. Jason. Not you, Jason. Back up. Oh, you big. Oh, there. Okay. Now I. Now, 9 times I've had to. Because of one person.
Somebody's got to do it.
I don't want to like force myself. I think I have my flag right here.
Hey, watch that ball. The ball right under you. I made it! Hey, don't do that.
I know how to do this. I know how to do that other stuff. I went through a few steps, not anyway, we lost half the team.
stop. Because again, if this drive is your ankle, you're not winning. The robot's winning. And then two member
Okay, as you're heading back, if you got an extra person, probably it's a good time to swap the batteries. I know we found out that there was a little bit of a oopsie with the radio situation. I forgot that the new radios have their very own voltage regulator, so when the power dips, the new radios keep you connected. The old radios, not so much. If you were having any of those issues and you didn't get swapped over to the old PoE injector that has the voltage regulation on it, we can do that, just so you won't have any problems moving forward. But also, you probably want a new battery, and if you keep the battery charged and it was kind of working, it'll probably keep kind of working. The next thing that we have to do is, if you get your laptops ready and your laptops connected back to the internet, we need to install a little bit more software. Yeah.
Are they filled? Or they
Okay, let's start getting this new software. So connect yourself to our internet here. I said connect to the internet like 3 times and didn't do it myself. We're going to be doing our autonomous mode programming in Path Planner. Basically, you're going to be able to, we just drove our code and you're going to be able to write your autonomous modes without having to do any actual Java coding. So, well, that's not entirely true, but that's mostly true. So this is going to be great. I think to get this though, you go to the Windows Store. I feel like there should be a link on their webpage, but I guess it's the GitHub. If you go to the Microsoft Store, you search for Path Planner. You get FRC Path Planner. Click the Get button. Let it do whatever it wants. All right, did everybody get Path Planner from the Microsoft Store? We good? Cool, because we got to download something else. Now we need to go to I can't believe you know the thing. Installing? So I searched for CTRE Phoenix 6, but if you want to type the thing in, it's v6.docs.ctr-electronics.com/en/stable. Scroll down to the bottom and get examples. We want GitHub examples. And we could go find the specific one. I think the easiest way is to just, if you click here where it says code, choose download zip. And then open up that folder. And just go ahead and unzip that somewhere. I'm going to do it to my desktop. Let me know when you guys have the unzipped folder ready. All right, it's going to be Java. Swerve with Path Planner is what we are looking for. I'm going to make a copy of that. Just on the desktop. I think you can rename the folder. I'll rename this. This is Swerve with Path Planner AADL, because that's where I am right now. You can put your team number. You can rename it however you want. And then when you have this folder ready to go, if you go back to VS Code, oh, I have two. And you do File. Actually, before we do that, open up your new Swerve with Path Planner. Go to SRC. Go to Main. Go to Java. Go to FRC. Go to Robot. And go to Generated. Then we need another window. Open up your program that we were just doing. Mine was called 2026 First Swerve Test. Also go to SRC, also go to Main, also go to Java, also go to FRC, also go to Robot, and Generated. Now it just makes extra sure. I think if you click up here, you can see the full path. Make sure you copy the one that we were just using, and you paste it on top of the one that we just created, our new path planner a new Swerve with Path Planner. So Path Planner, and this one was the Swerve test that we were doing. I copied the file over, so now all of my tuner constants are in the new project file. Then you can close these. And in WPI Live, we're going to do File, Open Folder, get the new folder, which I called mine Swerve with Path Planner AADL. Say Select Folder. And we should now have the new code with all the extra things we need. And then it's that first open. It's going to do its kind of first build when you open it up. Make sure everything's there, everything's working, etc. We got a couple yellow things, and that's fine. So like this yellow thing is because there is a camera called a Limelight. The Limelight can do things. I don't know if you've seen this, but there are these April tags all over the field. They're like fancy QR codes or unfancy QR codes, depending on how you look at it. And this camera can basically find those and help like localize the robot on the field based on what it sees. So this sort of has some of the stuff you need to incorporate the Limelight built in. If you see yellow squiggly lines, that's basically saying, hey, you imported this library and you're not really ever using it. You might be wasting your time. It's not going to hurt anything, so you can ignore yellow stuff. You could also probably delete those lines and it would be fine. If you go into Generated and Tuner Constants, what I want you to do is just to verify that you copied your constants over. If you scroll down, I guess I don't know what the default is. So if you scroll down to where you have like front left drive motor ID and front left steer motor ID and front left encoder ID, those should be the numbers you put in.
Pretty sure a camcorder is 1, 2, 3, 4. So
I think the default would not be 1, 2, 3. You can also see the steer ratio, 12 to 1. We know that's right. But make sure your stuff is updated. And then we are going to run Path Planner, FRC Path Planner. OK, we'll do this step 2 because I think this is pretty easy. Go ahead and do Open Robot Project. Find your project wherever you saved it. It wants the whole folder. So mine, again, was Swerve with Path Planner AADL. You can either select it here, open that folder, and then say Open Project. Hey, there's a new field image available. I think we would like to have that. And you should see the little pictures that are showing up look like this field, not like last year's field. OK, so in Path Planner, we're kind of set up to do a couple different things. We can make paths, and we can make autos. A path is basically a path for the robot to go from one point to another. It can have as many stops along the way as you want. So if you want to go from one side of the field to the other, you want to go from right in front of the hub to right behind the hub, you obviously would have to move over, go over the bump, and then move back over to be in that position. So that would be multiple waypoints, like starting waypoint, over waypoint, cross the bump waypoint, back into position waypoint. That would be one path. Our auto then can connect those paths and other commands together and chain them together. So maybe you need to do that path, and then you're ready to launch the balls. That would be the next step. Then you drive somewhere else. So we can use autos to chain together a bunch of paths and a bunch of commands for other functions on the robot if we have them. Let's click on Simple Path that's here. Click on the little edit. Let me go full screen, too. This is the path that's starting out there. So the path is saying, hey, you start here, you end here. And it can have fancy curves, right? So start here, end here, going through here. This is an intermediate point. OK, let's go through the options that we have here. You can click on this and drag your starting point wherever you want. Guess what? If you want to start with auto mode lined up right in front of the goal, you need to put your starting point somewhere around here, right? If you have your auto mode that's starting off on the side, you got to put your first thing wherever that's going to be. And in this case, that's what our first step is going to be. And let's do an auto mode where you start right in front of it. The next thing about this is this yellow one here. Does the length of it? Oh, the length of it does do stuff. This yellow thing is basically, so the whole thing is a spline. The yellow thing is kind of telling you what direction you want to enter or leave that first starting green position from. So you can sort of see, like, if I drag it way back this way, it says to go back on this angle. So it's going to follow that path out. Let's do something more reasonable for what we might be trying to do in auto mode. Let's say, hey, if we want to start here, maybe we want to drive to end in this position where you can then release the, I don't know what they're called, the human player balls into the robot so you can reload after you launched. Well, now we can change our entry and exit position. So like when you go up against the driver station wall to collect those balls, if you go in, if I say my entry point is on this angle, Swerve fixes this a little bit. But if you clip the wall as you're trying to move in and rotate in, you might never get flat against the wall. And you really want to be flat against the wall for those balls to drop in the hopper. So this is a situation where I probably want my entry to be very straight, perpendicular to the wall. And then why would we want an intermediate part of our path? Well, what if another robot is starting here? I can't just drive through that point. So maybe we know what our teammates are doing, and this is a safe intermediate point. Now I'm going to be like, OK, well, I want to enter and exit. There we go. Don't get it twisted up. I want to enter and exit kind of like this way. And this one, maybe I want to go a little bit more directly to that first waypoint. So this is a much cleaner path right into that position. You can control how sort of smooth and direct the path is and how much it isn't. Now, there's also the ability down here in Path Optimizer for you to click Optimize. And it like calculates through trial and error, I think. That's why you get the line slowly changing. But it thinks this is the fastest way for me to go through those waypoints, which means the way I drag stuff was pretty close. Not terrible. It says that optimized runtime would be 2.78 seconds. Currently, it thinks it would take me 3.07 seconds. So it saved me a quarter of a second by optimizing. If I say nah, but I do something weird, like, I don't know, we move some of these things around, and we've got it doing kind of crazy stuff, if you optimize, it's still going to work its way back to roughly the same thing it did before. 2.79 seconds this time, so it did a little worse. But it basically came back to the same path, right? So you can spend some time getting things a little bit right, but usually, and again, I don't have the most experience for this, so we're going to all look at Corey and see if he shakes his head yes or no. Usually, I just kind of get it close and then hit the optimize button. Right. So, and this is a good point. So if we don't care about the final thing, it's good, but he is right. So he said the ending point is no longer straight into the wall. So then after it's optimized, you can go back and adjust that last bit. So the rest of your path is still optimized, and now we have that little bit straighter trajectory in. And if this is still, because it's still kind of curving, it's only straight at the last second, right? If you want it to be a little more, you can stretch it out a little more. And that feels pretty good to me. All right. I think we want to kind of make one work real fast. So I think if we put this simple path that we just created, and hopefully you guys have something similar to this, if we throw this into an auto mode, we should be able to then take our robot over to the field and run that auto mode and see if it follows the path.
You are turning in the middle of the path. I'm not sure if you want that.
Ah, this is a good point, too. I kind of just drag stuff around. I didn't mention what this little dot is. So this little dot is the quote-unquote front of your robot. So I have it so the front is facing the goal. And over here, I have it so the front is facing away from the wall. Guess what? For our robot to launch, the back has to be facing the goal. And the back has to be facing the wall to load in. So we can have a rotation here. Or we can, it doesn't really matter. It doesn't know what's front and back. When you set your robot on the field, the way you set the robot on the field, it assumes it's facing the way that it's facing. That's the starting position. So, you could do everything opposite. I think we should fix this, but we're not going to because I want to get it to work, and I want to get past that first hurdle of making it work. But you see how it's turning to come into this middle point and then turning back? If I change this position to be straightforward as well, it's no longer going to make that turn. It's just going to slide around. Now, I'm dragging stuff around. Honestly, dragging stuff around is probably good enough for most of what you're going to do. But you can go into the specific waypoint, and you can choose your heading at that waypoint. You can choose the exact position on the field. So if you find, we got to move 4 more inches one way, you can change it here. This is in meters, though, so you got to do your conversions if you're measuring in inches. And you can see the starting waypoint, we start at 175.015 degrees. If I copy that and I go to waypoint 1, I can put that in as well.
Heading is direction, not...
just kidding, don't do that.
You want the rotation targets to do that.
Right.
Or the final and start position.
So you can do, sorry, you can hit this button to add a rotation target.
Ideal starting six at the very bottom. That's your rotation.
Ah.
And then if you want to change the midpoints, that's under rotation targets.
Yeah, shouldn't this add one?
I don't know what that does. Just hover it.
Add rotation target at waypoint.
Oh, so go.
Oh, we need the, yeah, okay. If you go to rotation target, sorry, because I clicked a million times. I have a million of these now. My bad, I forgot. So if you add one rotation target, if you go into here, you can choose what the rotation target should be, which could be 0 degrees. And then 0 degrees, press enter. And then up here, oh, sorry, it is already.
Rotation target 1 is the middle point.
Yeah, it is already associated with it. So I think it straightened this up to exactly the same number of degrees. So now it's not off by the 2 degrees that was the closest I could get by dragging it. All right, let's go back out to the main one here. And I think actually it's already set up for us. So there is this test. This is our auto mode. Click on that. Auto mode is set up as a sequential group. Basically, that means it's going to either run a path or run a command. And it's going to do them in order. So it runs simple path 1. And then if we add something else here, like, for example, let's do one. Click the plus. Click a... What is that? Hey, click wait command. Now we have a wait command. And so we can put the wait command in. It'll be hard to know that the wait command is there. But you could, say, hey, let's wait for 1 second. We drive there, we wait for 1 second for the human player to dump the balls. And that's a crazy low amount of time. But again, we're faking stuff, so we're going to fix it later. Then, for example, we could do another path after that wait command. It'll drive somewhere else. We could do another wait, another path. And then also in here is this named command. So when we finally add the kitbot commands, kitbot has 3 commands, I believe. One is to eject balls out the front, one is to launch the balls, and one is to intake the balls. You could add those in. So you could say, hey, back up a little, launch, wait for 10 seconds while it's launching, or the launch could have the 10-second wait built in. I think you can do it either way. Drive over here, wait 5 seconds for the human player to load the balls, drive back. And that's how we build our auto modes. OK. So this exists now as an auto mode. I think I don't know if you need to save it. I just press Control S like 15 times because I'm that kind of person. And then once you've done that, click back on VS Code. If you go to deploy, there's now a path planner folder. If you open that path planner folder up, you'll see autos and paths. If you open paths up, look, this is the path we created. It's all of the waypoints, all of the angles, max velocities. I don't know. Don't worry about it. It does it for you. And then if you go to autos, test auto is basically giving us the sequential thing. Follow simple path, wait for 1 second, and we're done. What's that? Oh. OK, we could do that. Let's click the the WPI Live icon. And we're going to show you the way that you can test your stuff a little bit faster without having to carry the robot on and off the field. This is not a 100% solution. Go ahead and choose Simulate Robot Code. Because this obviously is not a real robot moving with real world things. But if your robot crashes into a wall in Sim, you probably want to fix it before you put your robot on the field. Or for example, your programmers want to program, but your mechanical team wants to attach the fuel mechanism. Do the sim stuff first while they're attaching the fuel mechanism, and then get the robot and tune it in the rest of the way. You can use real driver station. Do I uncheck the other one? Cool. Say OK. Yeah. So if you go to network tables, choose pose. And then if you don't have superhuman eyes, make it bigger. Yeah. And then go to network tables, smart dashboard, and then we want, I guess it's auto mode probably. Yeah. So this is our smart dashboard. This is our auto mode. This is what selects our auto modes. Right now we have tests and none. As we add auto modes, you will have more options on this pull-down menu. Make sure you are on tests, because that's the code we tested. And then, in order to run this, if you pop up your driver station, go to autonomous mode. Make sure your robot is not on, too, by the way, just to be super safe. Click enable, and your robot should follow the path. You can disable, and I think you can do it again, and it should follow the path again. This might be a good place where you say, oops, I drove through the tower. That's not good. Oops, I am facing the wrong way. Things like that. So you can really do the sims to dial things in close, and then you got more time to do stuff. So I think we do want to see the robots run on this step, though. So if you, yeah, we might hit the wall, but we got bumpers, right? We got bumpers. It's fine. It's totally fine. So, but we don't have slow speed. We should slow the speed down a little bit. Go back to Path Planner. Get your menu in the top left in Path Planner. And then we're going to get settings down here. OK, and we should talk about these settings, too, just in general. These settings, if you never touch them, things probably work good enough. If you want to tune things in, if you're trying to shave every last bit off and you want whatever, you can go in here. Our robot is not 75 kilograms. That would be like 160 pounds or something. Our robot right now probably weighs 50 pounds. I don't know, 40. Maybe less even. So you could change that. Moment of inertia is like, when things aren't moving and you want to make them move, you got to overcome the inertia. Newton's third law? Is that the right one? Second law is F equals ma. First law is the inertia one? All right, thank you. I know there are 3 of them. I know it's 1. So it turns out the shape that your robot is affects its inertia. If you're big and tall, it's going to be a little bit different than if you're just the tiny thing here. Whatever, I've never changed this. You can change your bumpers. So what this can do is this can make it so your bumpers, when you have a wall and you're going to hit the wall, it might say, hey, this path is going to hit a wall. If your bumpers hit the wall now, it'll tell you that. If you have no bumpers, then you might be able to get too close to the wall because your bumpers will hit. If you have things sticking off the robot, you can kind of add a robot feature for that and draw those things on. We don't have that problem, so we're not going to worry about it. I think it's the module offsets from our code, so I don't think we have to worry about that. And then we have our true max drive speed. We want this number to not be whatever number it is. We want it to be slower. I would say, I don't know, like half maybe? 40%? 2? Let's do 2. 2 meters per second, 6 feet per second is not slow, but not scary. That seems like OK. You can close this. I don't know if you need to save, but I'm going to Control S a bunch. Yeah, we can now, if we open our path, we've now broken everything. Oops.
Maybe reset that to 4.7.
Change it somewhere else.
Yeah. I'm going to check something. Is there an option in here? Constraints. Ah, here.
Okay.
Yeah, we can just change that.
Okay. I just really wanted you guys to practice with the settings, but if you go back to the settings, change your true max drive speed to 4.7. This also, in theory, you could change this number to match the calculated free speed that was in the constant file that we changed before to be times 0.3 instead of 1.0, because that is the calculated free speed. If this number is too big, though, and your robot can't actually go that fast, then your robot might do things that it can't, try to do things that it can't do. If this number is too small, except if you go to 2 apparently, it should be okay. It just means your robot will go a little slower. But it does seem like it's better for us to go into the path and go down to the global constraints. And in global constraints, there is a max velocity. And right now, our max velocity is 3 meters per second. That's something that you could probably turn up as well if you're really trying to do a lot and drive a lot of places in auto mode. But let's turn ours down a little bit more. Let's do 2. And you can see we increased our path time by about 0.55 seconds, which does not seem like it's going that slow, but whatever. Let's find out what happens. OK, then we can go back. At this point, save it again. And then go back to Swerve with Path Planner in VS Code in WPI Live. This time, we're going to hit the WPI Live button. We're not going to simulate. We're going to deploy it. We're going to send it to the robot. Now, of course, if you want to actually deploy your code and not get the error I'm about to get, you should turn your robot on and connect to the robot's wireless network. Yeah. So if you get errors and it doesn't deploy, you might, if you get build failed and whatever, if you see the stack trace stuff, if you see are you connected to the robot and is it on? Probably you should connect to the robot and turn it on. I'm going to let all of your robots be our example, though, so I'm not going to bother for this step. So our goal is let's go out to the field. You can start on either side, probably one robot at a time, so take a couple turns, see if your robot does what we expect, and then we'll come back and we'll start adding more.
Put it down right in front of the hub. The hub's in the right spot. Just put it, or no, it's not. Someone hit it really hard.
I dropped something.
You should set it over here where your auto starts, right?
Oh wait, I don't know where it starts. I'm not blind.
Did you not do the pepper?
I do everything. I do everything but that.
What does your path cleaner look like? Do you have a path?
Ask that.
You have a path.
What does it look like?
Oh, there's a default path on it.
They can look in there.
Just check on the path.
What does the python look like? Jace, don't shoot it.
Is that this robot? Before you run anything, can you just shut the gates on your side?
Okay.
Lift the front one up. Take the bar. Take the bar. Line it up. Drop it. Take.
You gotta line it up in between.
I know.
You should do field reset. You got this.
No. No.
It's fun.
I don't want to do it. You do.
I feel too.
Huh?
Yeah. Field reset's fun. You get the best spot and you don't have to scout.
So if you are not able to deploy your robot code, it might be that, because we brought the example project over, but we didn't add our team number. So from the WPI palette, you can do set team number. If you pick set team number here, it says enter a team number and press enter to confirm. And then my robot for this workshop is 9999 and then hit enter. So that will now set it to your team number. So if it's not working, go ahead and do that. Do the, again, pick here, do set team number, put your team number in, hit enter, and then try to deploy again. Again, also making sure you're connected to the Wi-Fi and your robot is on and all that.
Put the ball in here.
We might be watching the video for the last part of it. That's okay.
I mean, yeah, I get it. Like we'll keep going. Hopefully, we get through everything on video, and then. Okay, if you try your last kind of update here, and then let's keep going. Okay. So if we look back at the path planner stuff, it seemed like when we drove, most of them did kind of this. Looked like it was in the right position-ish on the side, like across the field, but didn't drive far enough. You know, so it's just a matter of moving this waypoint to wherever you need to. And when you get close and you're like, now I need to do it a little more this way, a little more that way, then instead of dragging, you might want to start changing the numbers around a little bit. And then you might be able to go back through all of the settings and get the distances to match up a little bit better. Like if you're always driving 10 feet and it's always going 11 feet, there are some places in the config files where you can set that up. But you can also just always make it go a little bit farther, and it's going to work out as well. All right, we're going to do a quick one here. And this is, we're going to simulate it. We won't run this auto mode. But right now, we only have an auto mode that's basically drive and wait. And we use the auto mode and the path that was there. So we want to create a brand new one so that you can see how that works. So if we do add a new path, we've got our new path here. Let's go into new path. And we're going to do things, we'll do things a little bit differently. If you put the robot in the starting position, put the robot in the starting position. The green one is the starting position, of course. And this time, just because we can, let's take the angle of the robot whatever starting position and rotate that around so it is actually starting with the back facing the goal, which is the direction that we would have to be to launch. And I'm guessing it's going to be true with this robot. I don't really know. But with Kitbot, and then I'm going to drag this around so that the out is facing the in, and then on this one as well, we can go to the endpoint heading 180. So it's facing the same way. And then oh, sorry. Whoops. So we want that 180, and then global end state at the bottom. We also want 180 because our robot is facing backwards. Cool. So now it's going straight back. Again, you could optimize this, but I think it's pretty optimized because I got my arrows pointing at each other, the exit and the entrance directions. And this is probably a little bit too far away, so I'm going to drag this just a little bit closer. When I tested with Kitbot, we wanted to back up roughly 20 to 30 inches away from the goal before launching. If you fired when you were right against the hub, some of the balls would catch the corner of the top of the hopper and get knocked back. But if you back up a foot or two, 2.5, they would all clear. So let's say the first step of our auto mode is to back up like this. OK, now if we go out, we can rename the path. And this is going to be, I mean, you can name these things however you want to keep them straight. But this might be like step 1, back up. Probably don't need, just a space is probably fine. So you could name this something like 1 back up. We could have then 2 something else, and you could know the numbers. Do it. That can be a double-edged sword, because when you find out, oops, you need one more path in the middle, you're going to end up with step number 2.5. But you can also just remember, hey, it's going to be back up, then go load, and then drive back, or whatever, right? So we have this backup step. This is great. Then we're going to need a new path. And one of the issues that we have is, in this new path, we need the new path, not simple path, we need our new path to start where this one ended. Right? Otherwise, our robot, I mean, I guess it doesn't technically have to, but our picture will not make sense. You could, in theory, grab all the endpoint data and type that over on your own. In here?
Yeah. So if you want links, that's what you're trying to do.
Yeah.
Go to the endpoints. No, at the top, click on endpoint.
Sorry, go to endpoint, and there's this link button here, link waypoint. So go back into our first step, which is 1 backup, and there's the link waypoint button. If you click the link waypoint button, that's going to basically save all of the data for this point, the position on the field, the heading of the robot, all that stuff. And we can choose what name we want to save it as. So this could be like end 1 backup. This is where we end 1 backup at. Confirm that. Then we go back. We go into, well, let's change new path already to 2. Let's call this drive to floor load. Because we kind of did a fake let's go human load. Let's go for the balls on the other side this time, just so you get a different look at it. Remember, you have to hit enter, he said to remind himself. Go into our second step. And now if you go to your waypoints, if you go to the start waypoint, choose the link waypoint button. This time, do the drag down and pick end 1 backup and confirm. And boom, our starting waypoint is now exactly where our last movement ended. And then we just do the same thing. We're like, OK, we need to be over here. Guess what? We need to be rotated kind of around. I found from testing that it's kind of nice to drive through these balls at a little bit of an angle. It seems to pick them up better than going straight into the wall. So I like randomly dragging. This is not an excuse for me to not have to set the specific angle in the other place, the end state angle that I keep forgetting where to click. And then, do your things. Choose the angles you want. Like if you really want to be prepared to sweep straight across, you could drag this one out a little bit so you get that good arc in. This is one where maybe you optimize the path, maybe you don't. I'm kind of happy with this. Okay, then we go back. Actually, go back into 2 drive to floor load. Go to the endpoint. Let's link that endpoint. This is going to be end 2 at floor load, maybe. Go back, add one more path, go to that new path, go to your waypoints. The starting waypoint from our links is going to be 2 end at floor load, confirm that. And then we might want to drive back, whoa, mouse, please don't do that to me, to roughly a position where we are comfortable launching from with an angle roughly Why can't I click on you? There we go. Roughly so the back of the robot is facing the goal. And again, you can, this one maybe is great. We're just driving back, so this might be a great, hey, let's optimize this path. OK, we now have 3 paths to this auto mode. We need to make a brand new auto mode, so click the plus on this side. And this auto mode basically is going to be launch, I don't know, floor load, then drive back. And you can be pretty descriptive on this. We'll show you explicitly again where you would pick this on the smart dashboard when the time comes. Did anybody else not press enter? Back up, launch, floor load, drive back, enter. All right, let's go into it. We have our sequential group here. We're going to add follow a path. First path is 1 back up. Then next thing we're going to do is a named command. What was the name? Launch. Our named command is going to be launch. Capital? Capital launch, I'm told. Launch is the name that we're going to create for the command to launch balls that does not exist yet on your robot, so your robot obviously will not launch. But I think if you put the commands in here, it's going to look for the command, that named command in your program. If it doesn't find it, it's going to be like, all right, cool, we're moving on. It doesn't like lock everything up. And then I think we want to add a wait here. And this wait is going to be how long do we want our launcher to launch for. When I was doing the other kitbot, I was doing like 9 or 10 seconds, but I had some issues where the balls weren't feeding nicely, and moving some of the wheels around for me, changing some of my spacer lengths, made that stop happening, and I was able to empty the hopper in probably 5 or 6 seconds. So I don't know, let's be aggressive and say 6 seconds. Add another one. Is the other name command to stop different, or we just move on? Yeah. So let's add one more name command after the 6 seconds have passed. And this one is stop. That is to stop launching. We're going to turn the launcher wheels off and everything like that. OK, so now we backed up, launched all the balls for 6 seconds, turned the launcher off. Now it's time to add another path. Now we're ready to go to the floor load. So we're going to do path 2, drive to floor load. And is this parallel command group?
We forgot to add the events for the intake on the auto, so we'll have to do that.
Right. So this next path goes all the way through the balls, which means our floor loader needs to be turned on before we get there, not after we get there. So add one more event, named command, drag this one up above to drive to floor load. And here I think it's called intake.
It is called intake. You can also start it in the middle of the path if you want.
Right. So yeah, I think it's simpler right now to do it this way, but Corey was saying we can start commands mid-path. So if like it's a long drive and you don't want to have all your motors going the whole time, you could wait until you're halfway there to turn it on or something like that. This is pretty short. I mean, this is like 3 seconds, 2 seconds if you turn up the speed, maybe 1.5 seconds if you really turn up the speed. So it's like it might take about that much time anyway. All right, and then we had one more, follow path. And this path is going to be new path. But we're going to learn something. If we go back to new path, whoops, and change the name now, it updates for us. Okay, probably at the end of this, we could stop intaking. I wouldn't stop intaking until we kind of get back to our end position, because a lot of times it will sort of start grabbing a ball, and the ball might hang on in the rollers for a little bit, so you need a few seconds to clear the last ball. So we want that couple seconds that it's driving back to keep intaking. Right? And then if auto mode didn't end, right, we could stop intaking, start launching again, launch those balls in, maybe drive somewhere else. We're probably out of time at the speeds we're driving. We're probably way over time at the speeds we're driving. But hopefully this is enough to kind of give you the idea of how to start with start a brand new auto mode, add paths, add your commands in between to get around the field. So let's see if this one works. I'm going to spam Control S because nobody's telling me it's not needed. Then we go back to WPI Live. And you'll see now we have backup, launch, and floor load and drive back. Our auto modes here, it's got all those different steps. All of our new paths are showing up. Drive back should have probably been called 3 drive back. Don't change the name here, change it in Path Planner. And then the last thing is if your sim window is still open, so it's going to look like generic Windows application. If this window is open and you sim again, bad things happen. I think it just doesn't work. Close this so your sim window is not open. And then in VS Code, we can hit the WPI icon and do simulate robot code. Sorry, check, use real driver station, say OK. I was just here waiting. Now the cool part is it remembers the changes we made. So we ain't got to do that anymore. Now, on the driver station, this is the driver station and the driver station smart dashboard. We have the ability now to choose between test, none, and our brand new auto mode. And actually, if you see back here, choosing it on this smart dashboard is also changing it here. So it's changing what's going to sim. When you go out to the field for a match, make sure you choose the right auto mode on this list. You will have this list. You're going to have at least 3, maybe as many as 8 auto modes, 10 auto modes. I don't know. You could have one that just sits there. You could have one that backs up and only launches. You could have one that backs up, launches, and then goes in human loads. One that backs up, launches, and goes in floor loads. One that backs up, launches, and crosses the field. If you had a hanger to your robot, you might have one that backs up, launches, goes in hangs, and then unhangs. You could have tons and tons of auto modes, so make sure you're picking the right ones here. And that's why I'm trying to be kind of descriptive with what it is, because if you have a lot, it matters. If you have 3, you can figure it out. OK, so pick the new one, and then go ahead and, on the driver station, go autonomous and enable. And your robot should back up, wait here for 6 seconds while it's launching, and then it should hopefully start driving over to the balls at some point. Man, 6 seconds is a long time when you're hoping you didn't mess up. But it did it, and it drove back. OK, so test your sim, see if that works. If it does, we know from our first test here that the sim does translate to the on-the-field stuff, but you will need additional tuning. So I'm going to close my sim down, because that's what I wanted to see. And once yours works, all right, we're going to check a few.
why they don't let me be an inspector. They're like, oh, you want to play? Go play. Why'd you tell him to hit the wall twice? Yeah, maybe don't tell him to do that. Yeah, this is like, if you do, this, so I know across the road you donate all this stuff, and this is like a little bit of across the road dog and monkey show, right? But like that aside, like,
try it.
Me too. I'm glad. Yeah. Right? Yeah. We're doing a restart.
Oh, the Java icon?
Yeah.
One of my emails is got a laptop that just has a generic password that
Java was created by That honestly isn't a bad thought. You just go to the center field and you just push them all out of the way so you can't have them. The really good teams are kind of like there, then go to the middle, try to pick those up.
yeah, that's the biggest issue. Someone able to hold the password.
That won't get to the middle. So go back. Back. You're on the pad right now.
Yeah, it's
Really good YouTube tutorial for that.
it's a tough That's exactly what we did. You got the RT as the code all right as a driver. I think it's all right if that's the only thing.
Oh, right. Yeah.
Laptop's not designed to do development. It's designed to be I know it's efficient for the program. That's the only well, robots not
Might try to get. Might be able to click on buttons like that. So I think we'd like a little bit of a high crowd. Ready?
They're almost there. I mean, it's back up at least. Just waiting for Windows to
To
give
be
us
more positive. Or maybe the computer will pick up on that and decide to make it harder for you. so far, nothing changes. When we go in, one thing changes. I'll show you. We're going to add another controller. We're going to add another Xbox controller. If you want it to be PlayStation controllers, I think there's a PlayStation controller class. Instead of saying new Xbox controller, you say new PlayStation whatever controller. And then you have to just translate all the buttons. Okay. So everywhere we're like .A, you got to use .square or something, right? I don't. The specific name. Because I know there was like
Oh, yeah.
class in there.
Just make sure that it's pre-pennant command. If you use just DualSense, it's not going to have the same look that it's on the other file.
Oh no, we are. Are you connected to me? That help for this first one? Basically, it's working. It's all right. You got it.
Yep. So, a little bit of fine-tuning, but it works.
Okay, I think we've resurrected the computer. We're ready to go. Now, there are a couple of different ways to do this. I think we're going to talk a bit about the code, but I don't know if I'm going to make you type every line. So if you go to the internets and you go to I was really hoping that was it. Whoops. If you go to the first Kitbot page, which Kitbot, it's my first result. Maybe that's because I've been searching for that for the last 3 weeks, but if you go to CAD and CAD drawings and software, there is a code guide for how they set stuff up. We're going to talk about some of the stuff. If you want more information or maybe a different explanation of some of the things, you can check out their code guide, which explains the code that they added. We're trying to basically reuse their code, again, as is, or as much as is as possible. We have to make some changes to it, and we have to add some things. But if you grab the javacode.zip here to download it, then if it were 3 o'clock in the afternoon, I would go through the whole code and make you type it in so that you learn it. But because it's 5:14 p.m., we're going to do some copy and pasting to move over the parts we want. We'll still discuss what's there and talk about why it's there and how it's going to work and make our changes that we need to make. But at least this way, we won't have to deal with typos for all the lines we got to do. Anyway, get that, unzip it somewhere. And okay, I didn't actually unzip it somewhere. I thought I already did. In Kitbot code, there are two ways that you can do this. So there's 2026 Kitbot classes and 2026 Kitbot inline. Their document kind of describes the differences and stuff like that. So I think what it boils down to is they think Kitbot classes is a little bit easier to understand, but is also spread out more, which I think makes it harder to understand. Kitbot inline does things a little bit more of a streamlined fashion, so there's less code, which I actually think makes it easier. They think that Kitbot inline also might be a better way to go for more complex things when you're doing stuff out. So anyway, I think we are going to work from Kitbot inline. And what we want to do, now that you have this folder, what you can actually do in WPI Live VS Code, you can do File, New Window. And you might want to do this, you might not. This thing, if you click, so if you're on the folder that shows all your files, you can click it again so you can get more code showing. But obviously, got to create some files and stuff or drag some files in order for it to work. On the new one, go ahead and do File, Open Folder. On my desktop, Kitbot code, Kitbot inline, select. Sure, do your thing. It's going to take a second for that first build over here. And again, you might need to be connected to the internet for this first build. Build failed. Yeah, the build should have failed. If we follow the red lines, we will see that everything that's Rev Robotics has failed us, which is expected, actually. Now, we don't care on this program because we're just going to be copying and pasting stuff from here. But before we do any copy and pasting, just so we don't get those ugly red things on our actual program, jump back over to our real one, our Swerve, et cetera, et cetera. I'm just going to go down to a random, I just want to be on a random Java file because, I don't know, it comforts me instead of seeing the JSON file of our path planning. Now, in order to use cross-the-road electronics stuff, we had to add the cross-the-road electronics library. But because we used the example, automatically did it for us. Now we need to use Rev Robotics stuff, our two Spark Maxes to control the launcher and the intake. So we need to add their libraries in as well. On the side menu here, the bottom one, WPI Vendor Dependencies. Click on that. Error loading web view. Error could not register. What? You guys have a list of stuff, right? It's not just, it's just me, right? When you click on it, you get nothing?
Is there an outage at this very moment in time?
We can try the other way. What was the command?
Show vendor dependencies.
show, you can do,
I think I just do vendor.
show vendor lib dependencies. Let's try it that way. Oh no, it just tries to open the same thing.
Okay.
Stand by.
I wish I understood. I don't have a landing page. I can't.
If you go to, I think there might be a place here that we can find it.
Yep, you're right. I sure hope they don't just have that now because that's the new one. Okay, get it. Well, I do know how to get to their resource for that.
There's an offline mode, right? Which should have to have a link to the file.
So maybe they did just get an outage. Revlib 2026.01.json, which is going to be this here, this here URL. I believe that this will work, and so it'll be install manage vendor libraries, install online, and then that's.
Okay. Yep. All right. Hey, this should work. The fact that this is not working is not usual. So if you are watching this again at home, hopefully stuff will pop up. When stuff pops up, all you do is scroll down till you find the Rev library. It would be Rev library or Rev lib, something like that. There will be an install button next to it. You click the install button and you're good to go. We're going to try to do this in a slightly different.
Go to the Rev example, the GitBot example, and WPI.
We're going to do this in a slightly different way.
Open vendor deps. They don't have their own library? I don't believe that. Open the other example. Or they should definitely have their own library.
Okay, well, let's just go back to typing the whole thing in. This is going to be fun for all. All right, we're going to do hit the WPI live thing. So this is a way we can try to grab it. I think we think there might be an outage somewhere, which is why it's not showing up, and it just happened to hit us at exactly the wrong moment. There's another way you can do it. If you do manage vendor libraries, we're going to install a new library online. And now we need to give it the URL of the library. So this is the awful part. https:// It's going to be software-metadata.rev software-metadata.revrobotics.com/capital capital L on lib -2026.json. And then what I'm going to do is remember how to type. All right, top line right there. And hopefully, whoever finishes typing this first and press enter finds out that it works. Anybody still trying to copy? All right. Let's unmagnifier because that's unusable. Press enter. Yeah, sure. Do the things. Okay, we are now ready to start moving stuff over that we're going to need to use. So the good news is, I think if you do your side-by-side windows, open up Java subsystems, all right, source Java subsystems, and like on ours, we have our command Swerve drivetrain. That's one of our subsystems. That's the drive on the robot. Now, the can fuel subsystem, or the fuel subsystem, is going to be the exact same as in the kitbot code. So if we drag this over, I think you can drop it right into the subsystems on the other window, and it's going to pop in. Now, it's going to be mad. Don't worry yet. We're going to do more stuff. It should be red. That's OK. The other one that we can drag over, but we're going to have to delete a bunch from, is constants.java. So if you drag constants.java, this doesn't go into subsystems. This just goes down in the Java FRC robot area. And we will have more to do, but we're going to start with those two. So if you have those two dragged over, let's go back big. Let's go to constants.java, and let's talk about what's happening in constants.java. And we're going to delete some things. OK, first thing is we scroll down, package frc.robot. Cool. This is all of our constants. Sorry, my laptop was about to turn off. OK. Do you see the section that says drive constants? Well, we're not using the kitbot drivetrain. We are, in fact, using the Swerve drivetrain that we already did. So we're going to delete lines 18 through 28, basically from the public static whatever with the open curly brace to the closed curly brace. Make it go away. Next up, fuel constants. What ID did you put for your feeder motor when we were doing the CAN ID on the Spark Maxes? Mine was 22, and my launcher motor was 21. Whatever those numbers were for you, you should type in here. All right, 60 amp current limit, good with that. This section you need to understand, and you need to know that it's here, and you need to know to be able to edit it. So in this section here, we have a bunch of doubles, basically. So when it says public static final, public means you can use it in any of the files in our project. Static final means it's not changing. This is what it is. This is what it's going to be. Double means it's a floating point number, so it can have decimals. And then this is the description for it. So when we are intaking balls in the robot, we want our feeder, which is the kind of the back motor shaft, to be spinning at a certain speed. And we want the intake, which is kind of the front two rollers, to be spinning at a certain speed. Turns out those speeds are not necessarily full power. So for the feeder, that is minus 12. That's basically saying full power on that one, 12 volts, minus 12 volts. For the intake, though, it's at minus 10 volts. Here's the thing. If you run the intake too fast, instead of the ball passing from the intake to the feeder to the hopper, it might miss the feeder roller, go up and get into the shooter, and pop out of the robot. So by slowing this down, this intake voltage down to 10 instead of 12, it makes that happen less. If your robot, when you run it and you're testing this, is still launching balls instead of picking them up, you can make that 9.5. You can make that 9. You might have to tune that value down. There's also the dead zone noodle. There's a pool noodle in the middle of the fuel mechanism. And playing with the thickness of that noodle and the position of that noodle might also help with this. So those are your two troubleshooting guides for that. Next, launching feeder voltage. This is how fast we want the feeder to spin when we're launching. This is pretty good. You probably won't have to touch it. Launching launcher voltage. If your balls are not launching high enough to get into the hub, you can turn this number up. If you make this number too big, though, sometimes that causes other problems. And sometimes you have to shoot from farther away from the hub. It's harder to aim when you're farther away from the hub, so that like close layup shot is better than trying to do whatever full power shot is. Spin up feeder voltage. So when we try to launch, what's going to happen is the launching wheels are going to turn on. They need about 1 second to get up to full speed. When they're speeding up, the feeder should not be feeding balls to the launcher. It should instead be going backwards to make sure the balls stay in the hopper. After 1 second of spin up time, then we change our feeder voltage to launching feeder voltage, which is a positive number instead of a negative number, so it spins the other way, which will now start feeding the balls into the launcher. We use these things in a bunch of different places in the code, I think. Less now than the version we did with Kitbot, but essentially, if anything is wrong, change it here. And it will change it everywhere that it's being used in the code in one fell swoop. You don't have to hunt through and find the few different places where it is. All right, next up, we got driver control port 0. We got operator control port 1. That's great. That's the port that we were dragging our controllers to in the driver station. 0 was where we needed to be to drive the Swerve drive. But here's the thing. This driver control port is referring to not our driver control with the Swerve. It's referring to the Kitbot chassis driver control. That line's got to go. And then all this on the bottom, this is just drive scaling, rotation scaling. This doesn't necessarily have to go, but it doesn't do anything for us. So we're going to delete it too. And we have now fixed our constant file, which is now basically just saying, hey, where's our motors plugged in? And what are our voltages we want to use when we're doing the different things? Oh, what was that? We keep the operator one. OK, then let's go into that canfuel_subsystem.java. This, I don't think we have to change anything, but we're going to run through it, and we're going to see what it's doing. OK, so we're importing the ability to use Spark Maxes, all that stuff. That's great. We're creating a Spark Max called feeder roller and intake roller. We're telling it that what the ID is for that, and we're telling it it's a brushed motor. Excellent. This part's a little weird. You could take this out. We're going to leave it because we're doing the copy and pasting. If you're rewriting the code on your own, I would skip this. But the smart dashboard that we can pop up that we pick our auto modes on, we can also put numbers there, and we can read numbers from there. So what this does is when you run the robot, the smart dashboard is going to get populated with an intake feeder voltage, an intake all those constants that we did are going to be on the smart dashboard. You'll actually be able to type numbers on the smart dashboard to change the value. So if you're popcorning balls because your intake is too fast, you'll be able to change it on the smart dashboard, see if it gets better, change it on the smart dashboard, see if it gets better, and when you find the good number, then you go back to constants, put it in constants, and that's your permanent every time you boot the robot value. So that saves you some time debugging. It's not strictly speaking needed, so if you're just trying to get code done and not worry about the extra stuff or not copying and pasting, you can always just change the constant value, deploy the code, and see if it works. It's just a little bit more tedious to have to wait for the deploy. OK, then we're writing our configs to it. This is setting the current limit. Looks like some of these things are deprecated. It's fine. Deprecated means it still works this year. And then we're going to be running out of battery finally on our house mic. So I'll keep talking loudly while maybe I change the battery. OK, so then what we're doing is when we want to intake, we're making this thing called intake, this class called intake, or command kind of called intake. And when we're intaking, we want to set the voltage for our feeder roller at feeder voltage for intaking. And we want to set the voltage for our launcher roller at well, the launcher roller, remember, is also the intake roller. So the feeder roller is separate, but all of the other things are connected together inside the robot. So you might see it called launcher roller, but it's also the intake. And so set the intake to the intake voltage. Makes sense. OK. Oh, that hurts less than yelling. Cool. Then we have one called launch. When we want to launch, what are we going to do? Well, we're going to set the feeder roller to our launching feeder voltage, and we're going to set our launcher roller to our launching launcher voltage. Makes sense? Whatever those, it's all basically saying those numbers in the constant file, that's what we send to the motor. And then we do have a stop thing, turn everything off, speed 0. We have a spin up. Remember I told you it takes like 1 second for it to spin up before you can launch? I did have a new one. I'm good. It takes 1 second to speed up before the launcher wheel's up to speed. That's what the spin up does. So during that, the feeder is going to go the feeder voltage during spin up, which was backwards to keep the balls in the hopper. And the launcher roller is going to do its launcher voltage, try to get up to full speed as fast as possible. And then we make a command called spin up. So when you run the command spin up, it's basically going to run this code. But for reasons you need it to be a command here that calls the method so you can do some slightly different things later. If you know the Javas deeply, then it makes sense. But if you're just trying to get your code working, don't worry about it. And then we also have to make a launch command, which is actually start launching. And then we have a periodic here that's empty, so it doesn't matter to us. All right, that is our CAN fuel subsystem. It is in. It is ready to go. Now, we have to go to one more place and make some changes, and that is our robot container. In the robot container, the first thing I want to do is we have to add the our other gamepad in here. So we kind of created the ability for the gamepad to exist for our operator controller, but we didn't actually like create the object that we can use. So in robot container, we haven't changed this yet, so it should be around line 41 that you see our Xbox controller situation happening here. Our new line is going to basically be the same as the line above it. So we're going to type this one by hand. Private, final, command. Oh, by the way, when you see it up here, just highlight it and hit tab or hit enter or click on it, autocomplete. Then it gets all the syntax right, the cases and whatnot. And then the next thing we write is operator controller. This is our name for it. So we get to choose what we want it to be called. So everywhere joystick is written, that's talking about the Swerve drive controller. You could do like op controller or op gamepad if you wanted. That part is just your name. So you can literally call it whatever you want. And that's going to equal a new command Xbox controller. And this one is not on port 0. This is on port 1. That's all. That's our only change. Change the name, change the port. You will notice that we got some yellow squigglies. It's saying, hey, you created this controller. You never use it. We're going to fix that in a second. All right. Then I think we can jump down to configure bindings. So bindings is kind of where we want to be. Let's see, we can go above everything. So go to the end of configure bindings where the open curly brace is and press enter. I'm going to do like an extra enter, so I got one space below before the drive stuff that was already there exists. So we got a little bit of spacing. You could do maybe 2 spaces if you prefer. I don't know, create a gap so you know the code we're adding and the code that was auto-generated for us. The bindings are basically where you say, hey, yo, when a button on a controller is pressed, here's what you should do. That's what these lines of code are going to do. Now we've got our op controller. Make sure you're tab completing so it gets your name right. And we're going to do dot. And now we can choose. I'm going to do left bumper because that's the code that was in the Kitbot version from first. But what button do you want? Our first thing that we're going to do is going to be intake. So what button on the gamepad do you want to be your intake button? Do you want it to be A? You want it to be X? You want it to be left bumper? Whatever it is, pick that from the list. So like if you want .A, it's .A. You want .left trigger, it's .left trigger. You want whatever. Don't use triggers. They're analog. Use a button. You got to do it a little bit differently if you use a trigger. Forget I even offered that as an option. Left bumper is what I'm going to use because, again, I told you that's what it was. But either bumpers or any of the A, B, X, Ys. And I did say I would mention, by the way, where we added this joystick gamepad here and did command Xbox controller, somebody was asking if you were going to do a PlayStation. This line of code would be different for PlayStation. And then if you did a PlayStation controller, when you do the dot, the things that show up will be PlayStation controller options, not Xbox controller options. So instead of A, you get square and whatever. Okay, after you pick your button, I don't think you, strictly speaking, have to hit enter here, but we're going to because it's going to be a really long line of code. And it's going to be dot while true. So basically, if the button is pressed, while it's true that the button is being pressed, this is what we do. We are going to control our timeout. We skip something. We're going to go back to the top. We're coming back here to finish this line, don't worry. But we're going to go back to the top. And wait, in, oh, yeah, when I see it. Oh, I see it now. I see it now. Hey, go to around line 44, where we have the command swerve drivetrain. We also have to basically include our fuel or ball system. So we're going to do, this line is going to look very similar to the line above it. I don't know. I think this one could be public or private. I guess maybe we match what's there. Public final. This is going to be our CAN fuel subsystem. So we basically have to, just like we said, hey, now we have a new gamepad and it's named this. We have to have a new CAN fuel subsystem and it's named this. And we're going to call it, I don't know, I'm going to call it the ball subsystem. You can call it the fuel subsystem if you prefer. That is equal to a brand new CAN fuel subsystem. All right, we're good with that? Let's go back down to where we left off with the dot while true. Inside of the parentheses of the while true, we are going to do, now we can type ball subsystem and it will let me autocomplete. Now we can complete ball system and it will let me autocomplete it. Dot. And we're going to do run end. And we're putting nothing inside this. So there are these nulls inside. Just get rid of them. So it should just be dot run end, open and close parentheses. And then we're going to add, making our own arrow, dash, and then right caret. And we're going to do ball subsystem dot intake. And you should have open close parentheses after the dot intake. We're going to do a comma, open and close parentheses, another arrow, and then ball subsystem dot stop, open and close parentheses. And then at the end of this line of code, you do in fact need a semicolon. Sorry, next to run end, we need one more open parentheses, and then at the very end, we need one more close. So this stuff is inside the run end. Okay, look. This looks weird. This is the format it needs to be to call our commands. But basically the way to think of it is, look, while you're holding down left bumper, kind of until we end, we're gonna run the intake. Then when we're done, when we're ending, we're gonna stop running the intake. So while the button's held down, we turn it on. Once we let go, when it ends, we turn it off. And so we're basically going to use the same format for our other two things, right? We have two more that we have to put in here. We have intaking, we have ejecting, and then we have launching, I think. So let's do the next one. It starts the same way, op controller dot. This is going to be the button that you want to use to launch balls. The default code has right bumper. We're going to press enter, and then on the next line, it's going to be another dot. And in this case, what we're going to do is it's another while true. So while this is true, we're going to do a couple things. This one is a little bit more complicated. So while you're holding the button down, the first thing we want to do is the ball subsystem dot spin up command dot. So spin up command is that 1 second while we're spinning up the motors, but the hopper, the feeder motor, is not feeding balls to the launcher yet. And we want this to run for 1 second. And we can do that by doing dot with timeout. So the timeout says run it for this long until the timeout goes off. And the amount of time we want is 1 second, but we have a constant for that, so we can change it just in our constants file. And the constant for that was spin up seconds. Then we got to sneak in between the two parentheses that are here. So we have one parentheses closing spin up seconds. We have another parentheses closing the while. This should be while true. Didn't I say true and then just autocomplete the wrong thing? While true, please. All right. So in between the one that would end the while true, we can do enter again. Basically, when I hit enter here and then start with a dot, it's just continuing the line of code. But if I didn't do that, this line of code, I would have to scroll back and forth like a dozen times for you to see what's going on. So we're doing a sequence here. First thing in the sequence is run the spin up for 1 second. And then, with parentheses, we're going to do the ball subsystem dot. We're going to send the launch command. It's time to launch. Then sneak between those two parentheses again. Got down to the next line. Another reason sometimes why it's done this way is this line and this line are kind of two different commands happening in sequential order. So by putting them on different lines, it's also easier for human people to see what's going on. All right, then on the next line, we're going to do dot finally do, which is going to trigger when you let go of the button. And finally do should have open close parentheses with nothing inside it. We need a new arrow. Ball subsystem dot, just stop. Enough already.
I thought that was good. Just stop. Just no more.
And let's see. Did I miss a parenthesis somewhere? There should be. Right here. Finally do, open parentheses. There we go. All right. 2 down. All we got left is eject. So eject basically runs stuff backwards, spits the balls back out the front. There are 2 uses for this that I can think of, but there are probably more. Use number 1, balls be getting stuck in your robot. You can go between load and eject to kind of shake them back and forth and see if you can clear jams. Use number 2, it is possible that if you collect a bunch of balls, you could drive over, park aiming somewhere where you want to spit the balls out to feed a teammate, and press the eject button to do that. You could probably also line up with, what's it called? The area on the side of the field with the bar that you got to go under? The trench. Anyway, that area. You could like spit the balls through there and roll them through and have them roll into the other area to maybe feed a teammate. Or you could spit them actually into the human player zone where the human player could then pick them up and do something with them. Seems silly to me to load the balls in your robot, feed them to the human player just to load them back in your own robot, so I probably wouldn't do that. All right, let's get our last command going here. Our last setup, op controller, dot. And the default button was, in fact, A, so I'm going to use A. You use the button you want your eject button to be. Do a little dot. Do a little while true. As long as you're holding this button down, we want to be ejecting. So this command is going to look almost identical to the very first command we did. With, I think, literally one change. So it is going to be ball subsystem dot run end, which gives us the ability to do something when we're ending. And the first null is going to be open close parentheses and an arrow. And the command in our subsystem that we want to run is ball subsystem dot eject. No semicolon if it adds it for you automatically. Okay, then on the other side of that comma, what do we want to do when we let go of the button and we're done running this particular command? Well, that is open close parentheses and the arrow ball subsystem dot stop. You do need a semicolon at the end of this one. And this time I think it added an extra. Yeah, I added an extra parentheses. Okay. Let me just frantically scan the rest of the code to make sure I'm not forgetting anything. I think that's it. I think we're set up here. In theory, and we're going to test I'll test everything at once on my robot. I know everybody here is tired, so if you want to see the results, feel free to stick around. If you don't want to see the results and you want to start packing up, that's fine. But there's one more bit of code we have to write. So in theory, right now, teleop works. We go teleop mode. I should be able to hit my buttons, do the things that it does. But in auto mode, do you remember in Path Planner, when we do our auto mode, we are doing these stop and intake things. Those were named commands. We have to do it that way. Well, we don't have to do it that way, but I think that is the best way to do it. But in order for that to work, we actually have to now create the named command, which basically points back to this and says do this, because our things that we want to happen in teleop and the things we want to happen in autonomous are basically the same, because these are very simple commands that we're running. But we have to register them as named commands so that Path Planner can find them, add them, and run them when the time comes. So let's go back up to, let's go back up, scroll up so far that you literally change, oh no, I'm in the right one. Robot container, we're going up to the very beginning of it, where it does public class robot container. Oh, sorry, yep. Public robot container inside of public class robot container is where we want to be. So this is where our auto mode gets built out. I'm guessing that yours might have more autonomous choices here. I'm not actually sure. Oh no, it won't show it here. Path Planner is adding them somewhere magically. We'll just go with that. If you wanted to add your own auto mode choices that had nothing to do with Path Planner, you would add them here so they show up on the smart dashboard. But why? Path Planner is so good. OK, we need to create our named commands now. So we're going to start with basically the first line underneath this. So around line 53 on mine, first line underneath robot container, open curly brace. We're going to do a named commands dot. We got to register that command. Now, the first part is going to be the name of the command. So we're going to do quote, quote, Well, okay, when you do quote once, it adds the second quote for you. So just, you know, a quote. Inside these quotes is the name of the command. Remember in Path Planner, we called it capital launch, we called it capital stop, we called it capital intake. I don't think we have an eject here, but I don't think we need an eject here, but you can add that later if you want. So what this means is when we're naming our commands, because we already did it in Path Planner, we got to use that same name. So let's start with capital launch. And what should our launch command actually do? Well, that is one of our ball subsystem things, .run. We're just going to run it once. And the thing we want to run once is once again going to be open and close curly brace, arrow, ball subsystem dot launch. And it added extra things for me. All right. Okay, so this should set up our ability to launch. Next thing we want to do is set up our ability to stop things from happening. That was the like turn the launcher and stuff off. Same line of code, basically named commands dot register that command. The name is going to be stop. That's what we put in Path Planner. And the command we want to run is once again ball subsystem dot run once. The thing we want to run once is open close parentheses arrow ball subsystem dot stop. Open close parentheses, and it keeps adding an extra parentheses for me, so I'm going to just delete that by hand. Name commands. .register command, name of this command is going to be, what do we have? Intake. We got to be able to intake with a capital I. Intake. And that command is going to be ball subsystem dot run once. Open close parentheses, get your little arrows going. Ball subsystem dot intake. And I'm getting rid of my extra parentheses and my extra semicolon. Let me get rid of this so that whole line fits. Now, as we were doing this, we figured out that we made a small mistake, a little boo-boo. In Path Planner, in our auto mode, the launch command will instantly start launching. It doesn't give it that 1 second of spin up time. From my testing with the other kitbot, if you don't do that 1 second of spin up time, the first ball probably misses, and then the rest go in. So we really should have a named command for spin up, so we're ready to go. So let's do one more named command. It's going to look very similar to the other ones. Register command. This is going to be, let's do capital spin. Are y'all fans of the camel case? Sure. Capital U on up. And that is once again going to be a ball subsystem dot run once. Inside of those parentheses, it's going to be our open close parentheses arrow, as always. And then it's going to be ball subsystem dot spin up. This time, it didn't add an extra parentheses, and I deleted one that needed to be there. Now, code is done. That was the last line of code. Control S like 40 times so you don't have to redo this. If we go back to Path Planner, though, we got to edit our backup, launch, and floor load and drive back Path Planner. Let's do add a plus, add a named command. It's going to add that down here at the bottom. The name command we want to add is Oh, we have to type the name. Sorry, spin up. With the capital S, the capital U. However you typed it in the code, that's how you got to type it. And then press enter. Then drag that up before launch. So now we back up, then we spin up, then we launch for 6 seconds, and then we proceed on our way. Now, spin up probably needs some time, but here's the thing. Here's the thing. I think spin up runs until we launch or tell it to stop. So what we can do, I think, we need time, right? We need 1 second. We could add a wait here for 1 second, but we got to back up. Backing up going to take about a second. We probably could put this before we back up. So now we're going to be spinning up. Oh, I guess, sorry. If we want to do that, you could do something in here called a parallel command group, which says do 2 things at the same time. So if we did a parallel command group, we could put back up and spin up in the same place. And I guess let's do that so you have that example. That's going to be down here. This is our parallel group. Drag your parallel group up to the top. That's the first thing we want to do. All the way to number 1 spot. Then in the parallel group, I think we can just drag that. Okay, we got to add a path, and we got to redo it. So you got to delete this one down here, our 1 backup, and then you got to add in the parallel group a named command called spin up, and then you got to delete this one. Now, in theory, if you take about 1 second to back up, because maybe you back up slowly, that's your spin up time, then you're ready to launch. If you back up and it takes about half a second, then you would still need, not in the parallel group anymore, you would need to go back and make sure you're on your sequential group to add a wait command that goes in between. So in this case, we don't have to wait for a full second. Maybe it takes 0.5 seconds to back up. So we do a 0.5 second wait instead of a full 1 second wait. Does it make a difference? Not much in this case, but now you know how you can make 2 things happen at one time. All right, we're going to save this, and then anybody here that wants to test any of this code, feel free. You got any questions not relating to the stuff we covered or relating to the stuff we covered, hang out, ask us, and then once we're done with those questions, I will try to get my robot on the field and run the auto modes and hopefully see the ball launching stuff happen if it's all together right. I can absolutely go back to VS Code. All right, and then as we get ready, or as I get ready to get my robot sent out to the field so we can test our teleop in autonomous mode, which should have everything now, I am, of course, going to deploy the robot code. Don't forget, when you go to do this, I've been on the internet the whole time, so I'm going to connect to my robot. I'm going to deploy that code just so that you don't think it magically got on the robot. And then we'll come back when we're ready to test this robot over on the field. So let's get a deploy running here. And let that do its thing. Even if you put your computer away, my auto-completing has failed me, so ball subsystem should not be init sendable. It should, in fact, be dot, what are we doing here? Intake. It should be dot intake. I thought I was there and I just hit tab instead of moving down. So let's delete that and get that lined up right. And then I'm going to redeploy my code, but make sure you get that change. Probably yours was right if you actually typed the thing I said.
Only if things don't work. Even close to it. Otherwise. I want to just make sure everybody's good. Yeah, good. Glad to hear that. Hope you have a good season. And again, like I said, we recorded this, so if anything you went fast at the end or whatever, you get back. Just watch it. Yeah, thanks for coming so much.
Good luck with your season. Wait, are you setting up here or do you want us to start?
On the other one, if you don't mind.
My tower was like
We built the top half, but it was like
CR, all this CR stuff. We have a support email. So as long as I support it, I think I will either me or Corey or one of the other engineers monitor that email. And personally, it's on. I go with it. Walk you through the
I'm gonna feel better if I appreciate this.
like I feel like I couldn't believe how much like better set up now. Like I actually feel like we're gonna actually have like be able to talk to people, play and like have it be
Yep.
Last year we showed up without our robot coded.
Okay, now you're showing up with a Swerve bot. So.
No, but we also have like a month before that
So, the other thing I recommend is, well, for our shopping for Canada, just remember that there's a bunch of troubleshooting and different troubleshooting steps. An exercise to do is just unplug a wire and then go find a student or someone and say, figure out what's wrong. And just that exercise, right? You know what's wrong, fix it. And then they figure out what's wrong. Because that is what's going to happen after this. And that is very good exercise. And if they're good at that, come see us. Because that's what the PSA is.
They have black
They get that intuition of, okay, wire's broken, or A would be this problem.
Whatever works.
Yeah.
We have to swap the radio on it.
Oh, is it the dad? Could you grab just a rev power module?
I think that's what he's doing.
Okay.
We are at Berrien Springs and
Getting it in there is going to be it's really
yeah, no,
so putting a power module on there is also something.
Stephen
Here. I'll get them. I'll get them.
It is in fact a flush cutter. So cutter, not a bad description. What did I do other than we don't have power module? Wait,
You guys must be exhausted.
wait, what? Hold on. Can't you just grab from the radio power over here? What is it? Yeah, because the old radio thing does have power that's required or something, but it's...
Another thing you can do is you can hijack one of the Wagos that are just powered and shove some power.
Yeah. Yeah. Well, no, we need all the way there.
Oh wait,
We need everything to work.
no, split it. It's not
Oh,
legal.
just
It's not legal.
hijack it. Yeah.
It's not legal.
Yes, you could tap in. You could tap in. That would be all right.
The rules say the radio must be powered off of only one guaranteed thing
And our rules say do what you want.
to make it move.
This ain't a competition.
Fire all these pictures and that's pretty cool. Like, do whatever you want. I'm trying to think of where the funnest place to be on the hill. Be in the bars, be in the processor, send on the actual field, I would do like a pull up on it. On the actual field, I'm going to try that one. What do you think? Go. With that distance, yes. I'm a are you like, on that next time?
balls out in the middle. So when you go over, you can floor load some of the far ones.
I can't see over there. So
where you can see. So if you're here, put them in this area, and you can pretend.
Do you want to? Do you want me on the outpost side so you can show the outpost, or?
No, don't.
Okay.
Nah, don't worry about it. Don't worry about it.
Driving?
Yeah. Go over the bump. We'll talk about. We'll just kind of be like, yeah, we're gonna test all the functions of the robot. Let's see how it does on the bump. Looks good.
You want to dump them on this side, Steph?
Good.
Yeah.
We're gonna make it. We're gonna make it. Oh man.
Slow start, but where's better for the cameras?
It's kind of like.
Middle. Dan.
It's bad to say in some ways.
Balls here or there? I don't think you can see well either. You said you might want a bunch of balls on the floor.
Yeah, you can leave a few wherever on this side, but I think also put some where he can see in the middle. So he goes over the bump and grabs some and then comes back over.
I was gonna say it feels a little bad because the team got it was late, they had a long drive, so they got tired and they left. But
That's just gonna be a mess. It is what it is.
we're still watching and fixing all the robots the whole time. We would not finish.
What I was thinking.
Yeah.
It's unfortunate that we didn't get to see it all, but
We did get it on film, and that's good too.
I'm gonna leave the box behind the hub.
Watch it again.
Right.
I think he was saying just so he wants to look good on camera. So we can kick some of these over into the, so it's not quite behind the hub, but like a little bit more.
Yeah.
To an area where he can see that.
This is funny. I think that's the wood.
Plus there are so many balls over there, you can't help but pick some up.
They're in the shot. Yeah.
The shot.
You guys basically ready to execute the plan? Okay. Alrighty. I'll be hanging out here. I'll be talking to the camera. I might turn around and ask you to do something. In which case, do it. Otherwise, we just make
shoot it this way or get it outside.
no mistakes. They'll all see it. It'll be immortalized. You miss a shot, everybody will see it forever. And then, if you're gonna be back here, you gotta say twice. For this part, for the shot. Which, yeah, do it.
Yeah, safety glasses.
I think you can get away with your glasses.
Looking for safety
There was a whole box of them right there.
On the end of that table. This is just too much like where they require safety glasses at the field that we gotta be right.
You make a good point. The microphone should, in fact, be on if we want to record. All right. Okay, as promised, we've got all that code in. No changes to the code since then. We brought the robot out to the field, so we're set up on the field. And I've got some of our cross-the-road helpers who came along to this workshop to help get everything set up and running. We're going to let them drive the robot around. We're going to do kind of a pseudo full match. So we're going to run our auto mode that we did. Now remember, this auto mode, it's kind of close. We threw it in Path Planner. We didn't really tune it in. So your auto mode should work better eventually. But we should see the robot back up, make some shots, drive towards the floor load balls-ish, and then drive back. We're going to look to see if there are any ball jams. We had some issues with that on the regular kitbot. And then we're just going to run it through the paces for a little bit. We'll maybe cross the bump, collect some balls, come back over, take some shots, floor load here, floor load there, try some ejecting, and just get a feel for the robot and let it do its thing. We'll see if anything is wrong with our teleop code or that autonomous code. And of course, your autonomouses are going to be much more numerous and much more varied. So, all right, let's do this. We're going to run our autonomous in 3, 2, 1, go. All right, definitely a little bit of a ball jam. That's all right. And we missed a little bit here, so that's something we got to tune in a little bit more. We're back. I think we were still loading, so that's fine. We'll look a little bit more at the balls inside of it, but in teleop, right, if this ever happens to you, just back up, shoot them in teleop. It's easy to shake the robot to get those balls free when you're not driving. All right, looks well, mostly good. All right, so this robot, from what we've seen driving around this weekend, can go over the bump if you go over forwards. If you try to go over sideways the long way, it's a little bit harder and it might get a little bit beached. And again, this is not much driver practice, so got to remember that the back side of the robot is the side that launches, and there, that ball. Hold on 1 second. If you bring the robot over here, bring the robot and stop. All right, so this ball, gonna carefully come in here. This ball was getting stuck right on the side here, and it was spinning in place. Now, this is exactly the same jam we saw on the non-Swerve kitbot that we built. So we have a little bit of a troubleshooting guide to that we I think we can show you here, or at the end of this driving section where we move some wheels around to get it to work. All right, let's go ahead and get some more balls floor loaded. Let's see that eject work on the balls as well. All right, something to note, if you really hit the middle hard, it is possible that you could bump up on the thing. You could hop over the bump. All right. And we're gonna pause for a second, and then we're gonna camera magic, because I gotta pop the bearing back in. Please don't move. Okay, that shaft collar is not tight. I guess we got to go to a not robot shot or something to cut this in. But we should be ready. Does it? Yeah, all right. Cool. All right, just pick up a few more and then come back and let's eject, because got a couple things loose on this robot. All right, the last thing we want to look at, right? So move over towards the middle of the field a little bit and face the camera. So we have our last function that we have to test, which is eject. You can use this to pass to your teammates, maybe pass from the middle of the field to the side, and you can use this to pass into the human player, where you might be able to find some cool strategies that work with that. So let's see if the eject works. Okay. And that one, you might have to go between intake and eject to get that one to go free. Sometimes you might have to launch it. This is getting stuck a little bit, I think, because of the pool noodle. So if you're running into this problem ejecting the balls, the thing you want to play with is that dead zone noodle. Maybe it's a little bit too thick or shifted a little bit too far forward so it's not able to go. And then it does seem like our spaces are a little wide here, so we're having some trouble with the bearings on this robot. All right, so if that one gets stuck too, you can also go to launch it just to get rid of it that way, or intake it back up and move on to the next ball. And I think we're good to stop anytime you have enough B-roll. cut. Park the robot here. Right in the corner so it's in the shot, and then I'm gonna say goodbye. All right, that is it. We put this kind of through its paces, maybe not as detailed as we did with the Kitbot, but you know, we're away at a different facility and we only have so much time to work through this. This robot seems like it's working great. The Swerve modules are actually better than I thought with this robot at going over the bump. So maneuverability around the field is going to be excellent with this robot. Just like in the Kitbot, and you can watch some of the rest of the Kitbot testing stuff, there's going to be some hiccups with the intake, with the launching, and with the ejecting, mostly playing with that pool noodle or adjusting the wheels like we showed in the other video. But that is it. Hopefully you're able to get this robot done, get some driver practice, and have a good season at the competitions. I'll be at a few of them, so hopefully I'll see you there. And that is it. That's a wrap for us on the Swerve Kitbot video series for Virtual Robotics Studio. One last time I'm going to say goodbye, but before we do, special thanks to Argosy, First, Cross the Road Electronics, West Coast Products, Aramco, and in this case, AADL, the Ann Arbor District Library, for hosting our workshop.